Bigger. Voice clear? Voice is clear? Laptop problem, everything is taken care. Correctly coming in laptop. Display also is okay. Just voice. Okay, I'll start. 1 minute, I'll just check here where I can see. Okay. Now see, we are designing the footing. Just for information, the footing is like this. One by one concept will come now. Make all the notes. This is a footing, plan. This is a plan here. This dimension and this dimensions are known for you. I think, tell me, and somewhere here is the column. Somewhere is the column. Tell me this dimension. I think 2.5 meter, if I remember correctly. This I don't remember. How much this one? Lengthwise is 2.5. Tell how much widthwise? 2 point. Widthwise. Lengthwise is 2.5. Should not do like last time. See, last time you nearly frustrated me by not giving answer. I suddenly stopped the class. Don't do that one. Little delay is there, but little lag is there. But that time it was beyond the limit. I know. I can hear my own voice here. Still answer is not coming. 2.2 meter. See. Remember, it's a continuation. Anybody new means they have to go to previous class, study and come. 2.2 meter. And then column side, if I remember, okay, not required. One of them is 0.23, other is 0.55, if I remember correctly. One of them is 0.23 meter, other is 0.55 meter. Now see, this is the plan. When you apply this all told earlier, when you apply the load this way, due to pressure, there will be lengthwise bending and widthwise bending. See, this is cross section. If I cut here, what I can see? I can see column and also footing. Now, there will be pressure here. In our case, pressure is uniform because axial load. But next question is the practical question. For everybody, important is next question. But then why this question? Unless this question is clear, that will not be clear. Okay, now, see, I told very clearly, this will bend like this. This will bend like this all over. Therefore, tension comes in the bottom. This is the reinforcement. So this I told, this is the reinforcement. This is a reinforcement steel, or this is AST for lengthwise bending. Leave it. Now, suppose you cut here, 2.2, let it come this side, 2.2 meter. If I cut here, look from this side, that is once again cross section. See, this is actually horizontal, it is not vertical. Looking this way, pressure will be like this. This will bend like this, this will bend like this. Okay, right. Therefore, reinforcement is like this. This is your AST for widthwise bending. And now, tell me, this is capital D, this also is capital D. Here capital D you cannot see. Why? This is a plan. Depth is perpendicular. Tell what value of D you are given. D is common. How much D? 400. What was D given? Overall depth. What is the overall depth given? Overall depth provided for a slab. Overall depth provided for the slab. How much? 450 millimeter. Every point understand correctly. Again I told you, 1 or 2 new comments are coming. If you are new, first time today, you won't understand. Today you attend the class, give your suggestion. At least something will be clear. Unless you study the last earlier question, when I started putting, from there you have to start. Okay, now, see, this reinforcement and this reinforcement, if you see, actually, this reinforcement, you can see here, maybe if you see like this reinforcement, you can see below here. Therefore, for lengthwise bending and widthwise bending, effective depth D will change. One of them will have slightly higher D, other will have slightly lesser D. Why? Common sense. See, bars are placed like this. If bars are placed like this, see, if the lengthwise bending you place the bar here, widthwise you place here, then effective depth for lengthwise bending will be up to this center. Effective depth for widthwise bending is up to this center. So lengthwise bending D, small d, will be more than this one by half of diameter of both. Or suppose you place widthwise bending steel here, lengthwise above that one, for some reason, then in the construction, this will have lesser D, more D. You cannot tell how they place it. See, sometimes you are footing, we are writing footing like this. For some of the column, footing can come this way. See, this way. Therefore, along the longer side, shorter side, you cannot tell how practically they provide the bars. Therefore, suppose there is a mistake. What will happen? Where D is lesser, if you take D more, it becomes weaker. See, you are unnecessarily taking more D. So to safeguard that one, practical design, what you will do? For both lengthwise bending steel and widthwise bending steel, we will take D least value. Why? Maybe see, for example, lengthwise bending D is 500 randomly. Widthwise bending steel D is, suppose you are using 12 mm diameter bar, it will become 488. Okay, then compared to the difference is 12 mm. So suppose you design this way, when they provide the steel, if they give other way, there will be problem. One of them will become over safe, other will become slightly weaker. So what you will do? I told you earlier, one pocket 500 rupees is there, other pocket 488 rupees is there. Safer side, imagine both the pockets you have 488 rupees, or you have 500 rupees. Your friend has got 488 rupees. How much you are going to spend? We will decide. Both of us spend 488 rupees. 12 rupees will still remain with you. So we took the least value. Tell what is that least value of D? Because some people are bound to ask when they watch. He took same D in both the directions. Actually D will change. I will tell them, come in front of me and ask. I will tell them, okay, you take that way. In the site, by chance, if they interchange, what will happen? Oh, then it is danger. By my calculation, the way I took D, what will happen? Nothing will happen. One of them will have 488. Other, even though it has got 500, you have taken only 488. We imagine both of them has 488. Same. So what is the D value? The D value 450. D value 450. We have taken at present 16 torr. I told you, at present you have taken 16 torr. With 16 torr, you have taken D equal to 450 minus 50 clear cover minus 1 full diameter 16 minus half of 16, that is 8. Don't give wrong values. 450 minus 50 minus 16 minus 8. 376 millimeter. So both we will take 376, so that in the site, if the interchange, we need not bother. Otherwise, you have to give instruction there. And when you design a multiple number of footings, these in the safe hall, it becomes problem to decide which is first D like that. Therefore, take lesser D. That's all. This concept clear? One of them has a little more strength. You imagine both are equal. This concept clear? I told you earlier. Because some people will ask, how you have taken same D? I will tell, keep quiet. Okay, clear. I use the same word, keep quiet. Don't argue if you don't know the subject. What all I told earlier, listen to it. Suddenly don't comment. Okay, now. Procedure sheet, right? First you find lengthwise bending moment and widthwise bending moment. Tell the answer. For lengthwise, what is the factored BM? And for lengthwise bending, tell me what is the factored BM? MU you got. Remember, you made the mistake. You should consider factored BM. I told repeatedly. You used working load conditions. Column load, axial load, vertical, pressure also, working load, pressure also you consider to working load. What BM you are getting is for working load, and without forgetting, you have to factor. Remember, you made the mistake. I only corrected it. Lengthwise bending, MU, how much? For lengthwise bending, what is MU? Tell correct value. Don't give wrong values. Lengthwise bending, MU. Little fast. See? These all you should have. If you don't know these values, if you have not noted down, class will be stopped now. Why? Who will go through that class now? I cannot go to, I can go through. Why? I have to go to that video, previous video, open it and search where I got bending moment. If you are not interested in learning, there is no point in struggling. Tell the answer. For lengthwise bending, factored BM. I told everything you should make a note. Because when I ask you, this much delay should not be there. Factored BM for lengthwise bending. Fast. See, delay. 110.175. I will take 110.2. Who want changes? I will take 110.2. 110.2 kilonewton meter. And what is the factored BM for widthwise bending? Why only one person is giving answer? What is the factored BM for widthwise bending? Widthwise bending, it will be slightly more, I think. Why? Because projection is slightly more. For widthwise BM, factored BM, fast. 112.5. Okay, first decimal sufficient. 112.5. Now onward, sometimes, see such a calculation, first decimal is okay. Okay, now. But remember, this is first decimal, but something else, maybe second decimal, third decimal later. Okay, over. Now, remember, Both has got D equal to 488 millimeter. Okay. Now, make a note in the procedure sheet. We considered lengthwise bending, found the BM. We considered widthwise bending, found the BM. Both of them are due to working load. Then we factored it and got factored BM. Then we equated the factored BM to maximum factored BM to MU limit and found what is the D required, effective depth D required. Then we added cover and also half diameter and one full diameter. That least D we considered. We got the overall depth required. Around 450 came. So you took overall depth of 450. No, not 450. It comes lesser. Overall depth of not 450. It came lesser. I don't know. Maybe 200 something came or 200 something came. 275, 280 like that. Then remember, I told depth of footing slab when you provide, if you provide based on bending, it will be 100% unsafe, because in case of this footing slab, shear is very critical. Two types of shears are there. One of them is punching shear, which already over last time. Other one is wide beam shear or one-way shear. Punching shear is two-way shear, all round. Wide beam shear, I will explain to you. Other shear. Both are equally critical. Therefore, accounting for that one, I told better take depth around. Tell me how much percent I told? I told some percent. At least take how much percent more? I told some percentage for you. This is, if you forget this one, nothing will happen. It will become unsafe. Then you have to redesign. 3-4 times you pay the penalty. Then you will remember that bending, depth based on bending is not sufficient. You have to increase. I told you at least 75% more. So many practically people take double. So we took around 75% more. We got depth of 450 mm, for which effective depth equal to how much? 376 millimeter. For which effective depth is 376 millimeter. Taken same for both bending. And now immediately we checked for punching shear, because to check for punching shear we need only effective depth. Yes, and we got safe. I told you if unsafe what to do, and remember, if unsafe you have to increase the depth. But if you increase the depth, remember, you need not increase too much, because as the depth increases, multiple benefits. The critical section will go away, which will reduce the punching effect, and resisting area becomes more. Therefore, suppose you got around 30% unsafe, overstress, increase the thickness by around 15-20%. But anyway, we got safe. See later, when I design the footing for column with axial load and biaxial bending, that is the practical problem. Initially, deliberately, I will take little lesser depth. Why? So that redesign comes there. Then you will learn redesign. And when you design by SAFE, you need not bother about punching shear, because punching shear check is performed by SAFE, ETABS&SAFE. It will give a number. I told you what is that number. That number I told should not be more than how much? When you design by SAFE, you need not check for punching shear. The SAFE will give you a number. That number should not be more than how much? That number should not be more than, I told you. On that day I told the meaning. Later I will not tell you. When I go to ETAB, when I continue my class for ETAB and SAFE, once this footing part is over, pure software, at that time when the footing comes, I will not tell. See, some newcomers will be there, because some people want to join. They contacted me now. We want to join only for software. I told earlier should have come. No, structural part we are knowing. See the answer. Answer. Those who know me, they will be laughing. Structural part we are knowing. So we want only software. They are bound to ask, sir, why it is one? I will tell, don't ask the question. I told you that number should not be more than 1. But why? If you should know why, you should know it is why. I don't know. Then on that day you told you have structural knowledge. That I told on that day. Now I am thinking, I don't know. Yes, be careful. Therefore, they were blindly tell, I know everything. I have seen this case plenty of times. Okay, now, this is over. But software part, I will make clear. Now, punching shear over. Now write, one more shear check you cannot do because for that shear, what I will call is shear causing wide diagonal tension. See, understanding important. For that shear, I will call one-way shear or usual shear. Usual mamuli. Or still more easier, see, this is a punching. That is diagonal tension crack. I will tell once again later. For checking that one, you should know what is the tension steel provided. Therefore, time being, you tell the footing. See, punching I have taken care. Okay. Bending moment I got. Now, next step will be to provide or to design, to provide longitudinal reinforcement. Reinforcement short form RI. Remember, longitudinal reinforcement in RCC means lengthwise reinforcement. When you take the cross section, you can see the steel. That is nothing but our AST. That's all. What you call AST, for it is called longitudinal reinforcement. Start first, right? Procedure sheet. See, problem I am telling. Procedure you have to write simultaneously, not now. Everything after the class, or after this class is over and after our class with axial load and BMs are over, then you go through all the problems. Under 3-4 times study, thoroughly understand, then write procedure so that it will remain permanently. See, start. AST calculation. First, consider one of them I will do, other you have to do it. Consider lengthwise bending, LWB. You write LWB in examination, they will throw the booklet outside. Don't write LWB. Lengthwise bending. Okay. Put data. Capital D is 450 millimeter and we have taken 16 torque. With 16 torque, we are taking D equal to 376 millimeter and also factored BM MU equal to 110.2 kilonewton meter is the MU over. Sagging BM that already told, bottom steel. Okay, start. R equal to 110.2, actually not required, 10 to the power 6 Newton millimeter. Okay, now we have to find AST. Section is singly reinforced. Why? Because your MU is less than MU limit. Y means basic structural knowledge. We found depth based equating MU to MU limit, then we gave more depth, so your MU limit is very high. Or already told you. Now, the equation to find AST is, again, first of all, I need not tell because those who are in the RCC group and those who are in the ETAB group, this is told 1,000 times. But there are newcomers. So when I take something, they should also understand. So equation is MU equal to, see, the equation to be used is MU equal to 0.87 Fy into AST into D into 1 minus AST Fy divided by BD FCK. One thing important, you should write both these bending moment. This MU equal to 112.5 and one more MU equal to 110 point something is for 1 meter strip. I told you. Therefore, wherever your B comes, B is 1000 millimeter. This I told you already. I unnecessary wasting time. I am only wasting time and telling. When you take a 1 meter strip, your B equal to 1 meter. Okay, start. Substituting. I am going for lengthwise bending. 110.2 into 10 to the power 6 equal to 0.87. I think I am taking, tell me, which concrete steel? Forgot. Most probably we are taking M25 concrete and FE 500 steel. Correct? Most probably you are taking, I don't remember now, M25 concrete and FE 500 steel. Correct? I don't remember. Yes or no? Correct? Okay. Then 0.87 into FY 500 into AST is the unknown. Remember, AST is the unknown. Into AST into D is 376 into bracket 1 minus once again AST into FY is 500 divided by B is 1000. Why? Because this bending moment is for 1 meter strip. D is 376, FCK is 25. Okay. This will give you a quadratic equation in terms of AST. And solve this equation. I told you applicable value is always least value. Those who are newcomers, you should know it. So write here simply solving and taking least value, tell the value of AST required first. You tell me the least value which is the AST required in mm square. Correctly answer. First, don't give wrong values. Don't give any wrong values. Okay, 699.81. Remember, I am depending on you 699.81. After some time, if someone tells, sir, wrong, I will close the class immediately. Why? Because at least one more person has to give the answer. After some time, if you tell wrong, then I cannot come back once again. I will get angry and stop the class. I told these things I get upset. Because so many are there, you participate and tell the answer. See, if technical mistake is there, I am responsible. If calculation mistake is there, one person I can't depend. So one more has to tell. One more should tell either same. Okay, one more told same. Okay, done. Thank you. 699.81 mm square. This is the tension steel required. Now, immediately you have to go to IS code. As per IS code, minimum steel means minimum steel to be provided in any direction, either lengthwise or widthwise, equal to foundation is a slab. So remember, for tar steel it is 0.12% of B into capital D. B into capital D or equal to 0.12 divided by 100 into B is 1000, capital D is 450. How much answer? What is the minimum steel you have to give? First, you should not give steel less than this value. You should see the requirement. How much minimum? Minimum to be given. Less than that you should not provide. 540 mm square. 540 mm square. Now compare. Therefore, your AST required equal to how much? Equal to 699.81 mm square is what? Is more than minimum steel of 540. Therefore, tell the answer. What is the AST to be provided. Remember, here I am explaining. When I go to column with axial load and biaxial bending, at that time pressure variation will change. It is a practical question. All I will explain. Finally, you reach the same stage. When you reach the same stage, what I will do? I will write 450, 376, 110.2, 699.81, 540, 681, more. Therefore, I will throw some numbers and walk out. I will throw some number and walk out. I will tell you, refer the old question, systematically complete. Tell the answer. How much AST provided now? How much? 699.81. You have to provide 81 mm square per meter strip. Okay. Now, make a note. Suppose by chance required steel is say around 495. Then you cannot give 495. IS code told at least 540. Minimum 540. Then cancel, provide 540. Over. Now, we have taken 16 torr. So with 16 torr, to provide this AST, find the number of bars. See, find number of bars. One important aspect. Find the number of bars. Actually, not number of bars. Tell why. I wrote deliberately. Whenever you take a strip of 1 meter, you are not finding number of bars. Tell me what you are finding. Whenever you consider a strip in a slab, in case of beam, you don't take strip. You take the full width, because by limited width, there you go for number of bars. But whenever a strip is taken, you should provide the steel within the strip. So you don't find number of bars. What do you find? What do you find? You do not find number of bars. Whenever strip is taken, whenever you, for design purpose, you consider a strip, later SAFE also will give same way answer. Tell what you have to find. You don't have to find number of bars. What you have to find? What you have to find? Not number of bars. What you have to find? Tell me. Forgot so many slab questions done for RCC batch and ETABS batch. General public, they should know. What you have to find? Not number of bars. This much difficulty. I should then stop the class. Whenever a strip is considered, you don't find number of bars. You can find, but don't find. Gone. This much. You find spacing. Okay, after half an hour. 16 torr, find spacing of bars. Spacing. Spacing formula, first of all, I should not give, you know it, but there are newcomers. What to do? Right. Formula for spacing is cross-sectional area of one bar by total steel area to be provided. I should not tell first of all, it will be insulting, multiplied by B. That is formula for spacing. Remember, little later, I will not tell once again. When you go for chuck for shear, by that time, spacing is decided. This is formula for finding spacing. Little later, when you go to chuck for shear, at that time, spacing is already decided. For the given spacing, we want to find area of steel actually provided. Then it will become, this will come this side, this will go that side. Then there I will write area of the steel provided equal to B divided by spacing into area of one bar. This you know it, correct or not? Those who came to my class, you know it. If you want spacing, it is area of one bar by total area into B. But once you know the spacing, if you want for that spacing, what is the actual steel provided? Answer is B divided by spacing, that gives number only, into area of one bar. Clear? Later I will not explain. You should write, better write now only, clear or not. Better you make a note here only. Or later you write, in the class you write a note here only, in a box. Later you need that way. Okay. Equal to area of one bar is pi by power of 16 square. Total area is 699.81 into 1000. Tell the answer. This will give spacing of bars, means at what spacing you have to provide the bars for lengthwise bending. Answer. Answer. Fast, fast. 287.31. 287.31 millimeter center to center is the spacing. Now, IS code told, see, now 1 minute now. You can make it 1 minute, leave it now. IS code told what? IS code told that when you provide the bars for main steel, you should not give a spacing more than, because why? If you give more spacing, steel will be lesser. As per IS code, maximum permissible spacing is 1. How much? One of them is 300 millimeter. Other one is 3 times the D. For lengthwise bending 3D, for widthwise bending also 3D. That is not distribution. In one-way slab, one of them is main bar, other is distribution. Then they told main bar 300 and 3D, distribution 450 and 5D. Here both are main bars. 3D equal to 3 into 376. What is the answer? 3 into 376. Answer. 3 into 376. Little fast. 3 into 376. 1128. 1128 millimeter. Now, see what is the spacing we got by design. 287.31. IS code told should not provide more than this one. This I am telling only for general public, those who are new. Those who are my usual students, if I explain, you should protest and tell, sir, why are you insulting us? This we know hundreds of times, but still. So what you have to compare this value, these values, and provide whichever is least. Therefore, provide how much? 16 torr at some spacing required for me. See, 287, then 300 and 1128. Tell me the least value. Tell the spacing. Fast spacing. Don't round off. So you have to provide a spacing of 280. All right, right here. Therefore, your spacing should not be more than how much? 287.31 millimeter. So provide 16 torr at 287, round off 280, sufficient, or 285, leave it, at 285 center to center. Now 1 minute now, I write a note here, note. 285 center to center if you provide, practically building owner will start shouting. He will tell, sir, this much. Then, sir, ಕನ್ನಡದಲ್ಲಿ ಹತ್ತಿರ ಕೊಡಿ ಸರ್. ಹಿಂದಿ, ಸರ್ ನಸ್ದೀಕ್ ಡಾಲ್ ದೋ. English, sir, little closer. What is this? You are not giving steel, you are giving steel at wide distances. He will tell, no. My neighboral building, that building and this building, I saw they give 6 inches, around 150, and you are giving nearly double. Sir, this is cheating, he will tell. So, it has not gone for drawing, subject to alteration later. Alteration is there. Alteration is there. Time being, you imagine 16 torr at 285. Later once you finish both the bending, I will do one thing. Practically, I will tell better you 285 you can't give. So you have to give closer. When you are giving closer, don't give 16 torr at 200 like that. What you do? Reduce the diameter and bring the bars closer. You are happy because no wastage. He is also happy because he is seeing steel close. See, that way. He does not know that steel is same. And one more thing, as the bars are closer and closer, good meshing will come and compactness will come, bending will be uniform and load distribution will be smooth then. So some alteration is there, but time being, lengthwise bending 16 torr at 285 is time being. Okay, now I completed lengthwise bending. Other, you have to do it now. I am not doing. See, I will sit there for 5 minutes now. I will come here, start. Consider not lengthwise bending, don't cut it. Right, once again. Consider widthwise bending. Once again do it. Start here. Once again come back here. Your D remains same, all remain same. Bending moment is not 110. How much? 112.5. 112.5 is the bending moment. Okay, now first get me AST required, minimum is same, then same way spacing and provide. Start. Don't waste time now. Yep. You take a rough sheet and prepare the answer. I will come, it is not a break. I will sit somewhere there only. I won't go outside. You change the numbers. I will write once again. But you should copy once again, not cut it. Within 5 minutes, give me the answer. Get ready. Within 5 minutes, you change the numericals and be ready with the answer. Or you can type what is AST required and what is the spacing. Minimum remains same. Minimum remains same. You should write what is the AST required and spacing required. Fast. Don't waste time. Maximum within 5 minutes. Okay, we'll start now. As usual, I am seeing few people are fluctuating. They are coming and going, coming and going. I don't consider them as participant. If you casually come for 5 minutes and leave, seriousness should be there. Attention means attention should be there. Seriously should participate. Learning should be once. It is not difficult. Once you understand all, there is nothing in structure engineering. I told in the last BSK class, when I told you about that overlapping principle, or I told, see, answer was tallying. Whatever way you do, I told it has to tally. And understand subject, there is nothing. Start. For this bending, don't waste time now. 110.2 cancelled. How much it is? 112.5. And then other things are same. Tell the AST required fast. AST required. 715.01. Okay. 715.01. 715 will do. Our children 1 paisa, sacrifice it. That 1 paisa, who want it? Leave it. 715 mm square. Minimum remains same. So answer is 715 mm square more than minimum to be provided 715. Okay. Spacing not 69. You should not do this way. Remember, don't do like this. You should substitute once again and make a fair copy. Don't try like me. Actually, I should write once again. This is save the time. Therefore, AST to be provided is how much? 715. Spacing. How much spacing? Spacing. Pi by 4 of 16 square by 715 into 1000. Spacing. 281.2. Nodi. 281.2. Okay. Maximum remains same. So spacing should not be more than 281.2. We will provide 16 torque at 280 center to center. Clear now? Just a revision. Bending moment changes. Other things remain same. One more revision. Clear or not? AST for widthwise bending. Now we are going to important part. Clear? Okay. Now make a note. This all I will remove now. See, this sketch I will remove. I last time told you correctly when the loading applied here, how is the cantilever action, everything I told, you should thoroughly remember now. See, start. All I will remove. Or, therefore, I write here now, therefore, at present, Ega, Sadhya, Abhi, at present, lengthwise bending, we are giving 16 torque at 285 center to center, and widthwise bending 16 torque at 280 center to center. Some will tell, why don't you make both equal? That people can make. That is your choice. But when you are learning, I want different values. Okay. Some rare cases what happens is, due to some problem, foundation becomes this way. See, this way. Then high projection will come here, low projection will come here. In such cases, maybe lengthwise steel can be 16 torque at 200. Widthwise steel can be 16 torque at only, say maybe it is 16 torque at 180. This can be 250 like that. It happens. So that is called little bad footing. I will, after finishing this question, I will tell you about that question practically. Okay, now this is over. Now make a note. Note. You write, I am not writing here. Spacing of 285, etc. practically not accepted. They will tell it is too high. Usually people, for a compact action, bars should be closer. Therefore, usually they do not want bars to be closer than 100 mm. Why? Too close. So usually, practically, people want spacing of above 100, that is 4 inches, and not more than 200. Usually people of that type. 100, less than 100 is what? Too close. Concreting problem. and more than 200, they will start telling this person is not providing steel, cheating. If it is a full contract, he will tell you took the money last time for foundation. Now see, you are giving steel at long, huge spacing. You should provide closer. I am getting worried. You can't tell him, see 16 tor, etc. You can't tell him. Therefore, what to do? Therefore, you see, this 285, you can't make 200. It is a waste of steel. What do you do? Instead of providing higher diameter, I told you earlier, initially consider higher diameter. Later, you change the diameter, decrease it. When you decrease the diameter, bars will come closer. Okay, people are happy. And second, compactness will come. And also, I told earlier, when you decrease the diameter, your D will increase. So, it is on safer side or unsafer side. I told you repeatedly earlier classes. If you take a diameter, later, if the diameter is decreased, it is on safer side or unsafer side. Because why? Spacing is closer. I told repeatedly earlier, decreasing the diameter results in slightly higher D. It is going to be safer side. So what you do is, see now, lengthwise bending at present 16 tor at 285, or you reduce to 12 tor. Tell the answer. If 12 tor, you should write to replace 16 tor, you should write all these things. 16 tor of 285, if you are going for 12 tor, tell me what should be the spacing. First, very thoroughly I told you in the RCC class and also in the ETAB class. General public, they should learn. These all I can't tell here. You think a little and tell. Now see, people will give the answer. 16 tor, 285, if you are replacing by 12 tor for the same amount of steel, spacing should be how much? What spacing earlier? 285. You divide it by that diameter square, multiply by new diameter square. So, first of all, I should not tell. Those who are new, right? Once you decide a spacing for a particular diameter, if you are changing the diameter, what do you have to do? That spacing you divide by old diameter square, multiply by the new proposed diameter square. Answer. How much? How much? 160.31. It comes to 160.31. So you can go for 12 tor at round of 160 millimeter center to center. This is good. That is around 6 inches. Now, by chance, now also it comes to around 190, 200. You can go to what tor? Tell me. Suppose you want a little more closer. Someone will tell 190, make a little closer. Don't waste steel. Tell me, replace by what diameter? Replace by how much diameter? Suppose you are further closer. Instead of 12 tor, change over to what tor? Instead of 10 tor. That's all. Okay. Now, same way for widthwise bending. Earlier we got 16 tor at how much? 280 center to center. Now, if you are replacing by 12 tor, the new spacing should be 280 old spacing divided by 16 square into 12 square. Tell the answer. 280 divided by 16 square into 12 square. Answer. How much? Oh, 10 tor badabadi. Answer. 157.5. 157.5 came. So provide 12 tor what? Or provide 12 tor at 157.5 is there. Round off little lesser side. Say that is 160. How much? Tell me. Little liberal. How much? Tell me. Liberal. 150 center to center. Okay. Right. Little liberal. Okay. Now make a final note. Very important. I will write here because, or I will write somewhere here because why? I need it. Later I will not explain. Therefore, longitudinal reinforcement or AST just now finalized is lengthwise bending. This is lengthwise bending steel. This way. Don't count number of bars, out of scale. This is steel for AST for lengthwise bending. Is the finalized steel is 12 torr at 160 center to center, whereas for widthwise bending, this is AST for widthwise bending. Our finalized is 12 torr at 150 center to center. Slab thickness is 450 millimeter. 450 millimeter. Okay. Tell me, clear or not? Slab thickness 450. Clear? First. Just a minute. Clear or not? No, but tell me, is it clear? Our final verdict now. Okay. Now, the most important, actually, you can make a note. When it was, see, when we took 16 torr, at that time, our D was 450 minus 50 minus 16 minus 16 by 2 equal to 376 millimeter. Okay. Now, you can continue with the same D. No problem. No problem. It is on safer side. But since you reduce the diameter, your D will become slightly more. Like suddenly you find that one extra 5 rupee coin is there. You first thought pocket money 300 rupees is there. Hello? Hello?
Sir, good evening, sir.
Good evening. I am in the class. I will call it later.
Okay, sir.
Okay. So, you earlier imagined you have 376 rupees. Okay. You can keep on buying things imagining 376. But actually, because of the diameter reduced, your D will increase. So, if you want, you can use. Suddenly you found that, see, one 2 rupee coin is extra. Okay, that also money. But when we changed 16 torr to 12 torr, your D will be, how much, tell me? 450 minus 50 minus 12 by 2. Tell the answer. Your D will be 450 minus 50 minus 12 by 2. Answer. How much? 382 millimeter. It is 382 millimeter. That is, tell me, earlier it was 376, now 382. Therefore, good or bad? Tell me, good or bad? Is it good or bad? Is it good or bad? It is good, right? Good. Therefore, your choice. What shall we do? Shall we continue with the D equal to 376 only? Means you continue the purchase imagining 376 rupees, or you can buy around ಎಷ್ಟದು ಜಾಸ್ತಿ ಏನಿಲ್ಲ 6 rupees more. You can buy 6 rupees one chocolate you can get. You can buy one extra chocolate also, or few chocolates. Coffee all will not come. So what you do? Tell me. What you do? Shall we continue with 376? If you continue 376, means I told you 1,000 times. Imagine lesser value of something which is strength supporting one is always safer side. Repeatedly told. When something is advantageous, if it increases, you can ignore it. Shall I continue with 376 or 382? Tell me. You decide. You decide. Shall I continue with 376 or 382? People usually practically want safe design. What? Tell me. What shall we do? Shall we continue with 376 or 382? We will continue with 376 only, because actually someone will comment, hey, you have changed that 16 tor to 12 tor. How your D is 376? It is now 382. I will tell them, I told it, but deliberately you can ignore this one. Nodi, beda. If you are ignoring, don't show calculation. So we will continue with D equal to 376 only. Right? That is, little reserve strength is there. Remember, it is reserve strength. Otherwise, you have to keep on revising. I will tell one more thing. One danger is there. Later, by chance, if you go for, when you check for shear, if it becomes unsafe, you may have to increase the steel. When you increase the steel, who knows? You may once again go back to 16 tor. Why? If heavy steel comes, if you take 382 and then if you take 370, 16 tor, it is unsafe. Why? D will reduce. Therefore, the small extra you tell, leave it. See, leave it. That's all. So we will continue with the D376 only. Start. Now, the most critical part of the slab. One more thing is there now. As soon as this example is over, I will tell you, when you design the slab by ETABS&SAFE, pressure check you need not do. Footing size you have to fix. For that one, I will tell an Excel sheet for you. Not at all. Because you should decide the footing size not based on only P. With the P, M1, M2. Their pressure change is there. I will explain to you. Don't worry. That Excel I will prepare in the class. Why? When you go to software, at that time I will ask you, open your Excel and type these values. Tell me what is the length and width. You should tell at that time. I cannot, during ETAP class, I cannot do all the structural calculation. It is pure software. So I will tell you, like see, deflection check. You got Excel sheet. When I design the slab by ETABS&SAFE, I will tell you, I will be sitting somewhere there. I won't be near the board. I will move the cursor and tell, see, this steel is 10 tor at 200. Now, tell me deflection, safe or not. You should open the Excel sheet I told you earlier and tell me safe or not. That way. So same way, Excel sheet required. Now, when you design the footing by software, length and width you have to fix. So many people, they decide by experience. Okay, that is leave it now. Then, you need not perform the pressure calculation, lengthwise projection, widthwise projection, bending moment, nothing. What you do? You create a model 2.5 by 2.2, place the column 0.23 by 0.55, apply a load of 850 kN. Done. Then tell, run. It will tell you the steel. It will tell you the steel, and also it will tell safe in punching or not. So punching you need not bother. ETAB will take care. But the next step, check for shear. What shear? Shear causing diagonal tension. I don't know why. ETAB people, they decided not to include it. They told, let them only do it. See, they decided, no, we are not programming. If everything you are doing, at least they want structural engineers to do this one. So they decided, structural engineers, they can decide, they can prepare Excel sheet. Therefore, for checking for shear, and one more thing, it's a very, very critical, you can make out now. So check for shear, you have to do manually. So that check for shear, that is shear causing what? Diagonal tension or one-way shear or our usual shear or called wide beam shear. This shear check you have to perform yourself only. Then it will be lengthy. In the practical design, it will take lot of time. So what to do? Better have what? Tell me. It is very ideal to have side by side what? Tell me. It is ideal to have side by side in laptop what? When the time comes for check for this shear, it is better side by side to have Excel sheet. But remember, I can prepare Excel sheet. I can't prepare. I don't know first of all anything about it. But I can give you instructions. But to carry out the instruction for you, you should know how to check for shear. So we are coming to, now we are coming to the most important part, most important part of footing design using ETABS&SAFE or software. Now you are coming to the most important part of footing design using ETABS&SAFE or software, that is check for shear. See, 1 minute. I will tell you what. This is the plan. This is a plan. This is the column. One of the shear is called punching shear. Punching shear, or also called as two-way shear. Two-way. How? It will punch here. See, it will punch here. Or if you see the, no tapering, here. This way. Punch, all round punch, not one place. All round punch. You can make a note there. He took a book and used a pen and pierced it. See, this way, punching shear or two-way shear. This you need not bother because it is inbuilt where? This check is inbuilt in what? This check you need not bother. It is inbuilt in where? It is inbuilt in software. And software, see, we manually checked it. Software also will do same thing, but all we want is a number will be displayed. We want that number not more than 1. That number is what? Actual punching shear stress divided by allowed shear stress, or like how much money you have, how much is the bill divided by how much money is there in the pocket. Everybody wants bill to be lesser, money in the pocket more. Ratio will come less than 1. Suppose bill is more, 120 rupees. Money in the pocket, 100 rupees. Ratio will come 1.2, unsafe, 20% excess. So that number should not be more than 1. Now, completely forget about this one. Why, tell me? Because when you enter software, we will not talk about this one. Because this is done by the SAFE only. And if you right click on that one, all the calculation we did in our class, you can see there. Perimeter, punching shear stress, tau c, all you can see there. If you want, some will tell, sir, we don't want. We believe you and also believe software. Okay. They will tell, I believe you and also software. Thank you. Leave it. Now, come to our other shear. Now the other shear. Don't call other shear wrong. That is the most important for design of footing by software, that is check for, you write check for one-way shear, or shear causing dt. Tell me, what is dt? I already told you, dt. Don't write dt. What you have to write? Not dt. Shear causing. dt means what? What is dt? No dt. I am writing dt because you should involve yourself. Diagonal tension, or you can tell this when you apply the check, it is like a beam shear, right? It is your usual beam shear. And one more thing, in case of beams, width is lesser. In case of foundation, width is more. So sometimes people call it as wide beam shear. Wide beam shear means what? Shearing like a beam only, shear check same as beam, but imagine it is a wide beam. Why? Footing has got 1 meter strip here, or not 1 meter. Actually, 2.2 meter and 2.5 meter is there. You are considering strip of 1 meter. That's all. Okay. These all you write. Okay. Now, most important, only once I will tell. See, or if you write a sketch for any one bending, lengthwise bending or widthwise bending, see, that shear crack will run like this. See, shear crack will run like this. Tell me, what is the angle for the shear crack? Tell me, what is the angle for the shear crack? What is the angle for a shear crack? Diagonal tension shear crack angle is 45 degrees. One thing forgotten, you write there, for punching shear, you take not 45 degree closer. Your critical section is at D by 2. For earlier, D by 2 when you consider punching. But for wide beam shear, most important, these all sketch you write. Then I will start now. I will rub everything. You should write all these things if you want to understand. First write. If you want to understand everything, you have to write. Critical section is considered actually as per IS code, considered at a distance of, tell the answer, not D by 2. For this shear, tell the answer. Critical section at what distance? Not D by 2. I told you earlier, IS code told for this critical section is considered at a distance of D, no by 2, D from face of the column. Nodi, I am writing using red color. Face of the column, that is for our problem at what distance? Tell me. 376 millimeter or 0.376 meter from face of column. For our question, your D is 376. 1 minute now. Actually, D is 382. So critical section will further go slightly by 6 mm, safer side. If the critical section goes away and away, it is safe. It is unsafe when the critical section is near to column. So by taking 376, what you are doing? You are checking for the worst case. Over. Now, so many things I told. Remember, this check required for both lengthwise bending and widthwise bending. Usually, you check for lengthwise bending. If you find very comfortably safe, widthwise bending will be somewhere there only. Slight changes. You can tell you are also safe. But if critical comes, unsafe comes, you have to check. Anyway, technically you have to check for both. Start. First, consider, I am starting now, consider lengthwise bending. I will complete the check for lengthwise bending. Then I will take a rest, break. Break means not 5 minutes, maybe around 10-12 minutes. Why? Because what we did for lengthwise bending, you have to repeat for widthwise bending. That you have to do it here only. But what I will do, once I finish the break, 10 minutes, I will give enough time for you. I will keep on writing here, and sketches I will remove, sketch will change, it will inverted. I will cut the previous value and make a new value. But you should write fair copy. Start. Consider lengthwise bending. See, first of all, what you require is, you write, no need of, see, for punching shear, what you see, this is also equally important. When you want to check for punching shear, you always show plan. See here, punching shear, show plan, because you look this way. Wide beam shear, you look from side. This is also right here. Look side fried. Lengthwise bending, go for front view. Go for front view. Write the front view now. See, this is the column. I will not explain once again. Front view. This is the footing. Later, when I go to column with axial load and bending, pressure will change. This much I will not explain. This much I will not explain. Column load is here. Okay, now there is pressure here. Pressure here. Net pressure. Tell the answer. What is the net pressure we got? 100 and I don't remember. Net pressure we got. Answer. Net pressure in kilonewton per meter square. Net pressure. Fast, fast. Who remembers? 154.545. Thank you. 100 and right here. The net pressure is 154.545 kilonewton per meter square. Meter square. Okay, now what you do is, from, see, there is critical section comes here. I will put red color. I want red color for that one. Critical section, I want red color. 376 millimeter. Critical section comes here. One comes here, one comes here. Both are equal. So this is your critical section at D equal to, now remember, we are going to find the shear force. This is in kilonewton per meter square. We want meter, 0.376 meter. And you also know that this base length, tell me, what is the projection on either side? Both are equal. So look only one side. Tell the projection. What is the lengthwise projection? Fast. Lengthwise projection. I forgot it. Lengthwise projection. You should have made note of all these things. 0.975 meter. Don't give wrong value after half an hour. Sir, it is widthwise means I will stop the class immediately. If you do such mistakes, I will surely stop the class. Correct, buddy. Now, if this is D, tell me what is this distance? Fast. How much? This is your D. See, this is your critical section. If this is critical section, not cross section, critical section, critical section for shear. And if this is 0.376, tell me what is this value? Answer. Itottu beka. 0.599 meter. 0.599 meter. Tell how I got? From 0.975 subtract 0.376 over. Now I want shear force at critical section. Critical section. I told you 1,000 times. What? When cantilever action is there, look free and side. kilonewton per meter square is nothing but kilonewton per meter if you take width of, I don't know how many times I told it, even though it is kilonewton per meter square, it is actually kilonewton per what? It is actually kilonewton per. Even though you write kilonewton per meter square, it is actually kilonewton per. It is actually kilonewton per meter when you consider what? A strip of 1 meter. So, shear force, look this side. This I told you on that day. See, when I go to shear, I will not explain. But what to do? I am not that type. I told earlier, when I do bending moment, I told you. See, later shear, I will tell you, load into distance. I will not explain once again. You agreed. But my teaching is not that way. Suddenly I get a feeling, somebody may not understand. Okay, done. So shear force equal to 154.545 is the load per unit length into this distance, 0.599. You should not look this side. If you look this side, you require column load and so many things. Cantilever action, look free hand side. Tell me the answer fast. In kilonewton, it will give you shear force in kilonewton. Kilonewton for what? 1 meter strip. It will give the shear force in kilonewton for 1 meter strip. Remember, in SAFE also, when you move the cursor, it will give you shear force per in kilonewton for 1 meter. I will tell you, after the Excel is over, you move the SAFE cursor by 0.376 meter. It will show you the answer. That's all you require. Answer. 92.572 kilonewton. 92.572 kilonewton. Now make a note. This shear is our usual shear. Remember now, this sketch I am removing. I am removing this sketch. Lengthwise steel is 12 tor 160. Widthwise steel is 12 tor 150. I am removing now. I will ask you spacing. You should tell what? Lengthwise steel spacing is steel is 12 tor 160. When I go to widthwise steel, you should tell 12 tor 150. Okay. If I got a smart board or what, an electronic board, this problem is gone because all I have to do is just move this way. Whenever I want, I can bring it back. That is not now. Later. Later I will go for it. Not right now. Right now, no idea. Okay, now start. Therefore, calculate shear stress. Shear stress, that is the actual shear stress. Or I write here, to make more clear, I will write actual shear stress. I should not write actual shear stress. That is called tau V, which IS code foolishly called, what name, tell me? I told earlier, IS code should not have used that word. They used the word nominal shear stress. Nominal shear stress. First of all, I will tell the committee, do not use the word nominal shear stress. When you tell nominal, what comes to mind? Ayo, nominal, namesake. You are spoiling the subject, giving trouble to me, people like me. You tell it's the average shear stress. Don't use the word nominal. They will tell what to do. Okay, David, I told you in the shear class that nominal is nonsense. It is the actual shear stress. Tau V equal to what? VU divided by BD. Start. Shear force how much? Shear force is 92.572 is in kilonewton, multiply by 10 to the power 3 divided by B is 1000, D is 376. Fast tell me what is shear stress tau V. Answer fast. Remember, this is the danger. This is actual shear stress developed. I should not tell. This is the actual shear stress developed. Why I am giving this much importance? Because for going to Excel sheet. Answer. As soon as this is over and widthwise over, I will today only prepare the Excel sheet. Today only I will prepare Excel sheet. Start. Answer. Yes. Somebody told, sir, factor shear force. I was testing you. If you substitute 92.572, it is a criminal offense. I told you, this is shear force for what load? This is shear force for working load. I wrote the word tau v. I told you earlier, deliberately I am asking you how much. If you make the mistake, it is a criminal offense. Therefore, most dangerous, as soon as you get shear force, is a working load, right? Therefore, factored shear force. Okay. At least today, someone got up from sleep. This mistake you are doing regularly. First time today in my class, someone told this value. Otherwise, I would have continued. Then, as usual, I will tell, what is this? When you will learn. When you will learn. If so, after telling so many times, still if you make the mistake, what I can do? At least at good, one person told there. Equal to what? 92.572 multiply by 1.5. What is the answer? It will come in kilonewton. Factored shear force. How much? Board fully visible? ಒಂದು ನಿಮಿಷ. How much answer? In case board is not visible, tell me immediately. By chance any part is not visible, immediately let me know. I will see the if corrections required. 138.86. 138.86. Thank you. At least today someone has correctly right of mind. 138.86. Now tell me, what is the shear stress? Remember, this is the danger because this is the shear stress coming. Answer. Give me in Newton per mm square. 0.3693. Danger kavali. I will put color. 0.3693 Newton per mm square is the actual stress developed. Now you need to get allowed stress, allowed shear stress. See, this is the danger. I used red color. Red means stop. Allowed is green. Why? Allowed means good. See, allowed is good. So I will use tau. Oh, it's green Allah. I will use a green color. Allowed is actually good. So I will use the word green color. Tau C. When I want green, I won't get it. Okay, finally got. See, green color means good. Tau C. This tau C is not your that tau C right there. For punching shear, your tau C was 0.25 root FCK. No. This tau C is for diagonal tension shear. Tell me. Tau C depends on what? Tell me. Tau C depends on fast answer. This is the shear, your usual shear. This is not punching shear. This tau C depends on not AST, PT provided. You write here. I am not writing. Percentage of tension reinforcement provided. And write. First of all, how many times I have tell? And write. PT provided is 100 into AST provided divided by BD. Now you need AST provided. See, now you need AST provided. AST provided equal to ulta. Remember, if you know the number of bars, easy. Now spacing known. I'm telling how many times. To find the spacing, formula is area of one bar by total area into B. If you want AST provided, it is B divided by spacing provided into cross-sectional area of one bar. Just now I told, I am not telling once again. B is 1000. Spacing provided. You provided what? 16 tor at how much? Tell me. 1 minute here. Your AST provided is what? 16 tor for lengthwise bending. Tell me, what is AST provided? 16 tor at, not 16 tor, sorry. It is 12 tor at what spacing? AST provided is 12 tor at what spacing? For lengthwise bending I am telling. I am asking for lengthwise bending. It is 12 tor at 160 center to center. Therefore, it is 1000 by 160 into pi by 4 of 12 square. Tell the answer fast. What is the AST provided in mm square per meter strip? This is AST provided per meter strip. Answer. ಇವತ್ತೇ ಬೇಕಿತ್ತು, ಇಲ್ಲ ಇವತ್ತೇ ಬೇಕು, ಇವಾಗಲೇ, ನಾಳೆ ಅಲ್ಲ. ಆನ್ಸರ್. Answer. Oh, 706.85. This is 706.85. Or therefore your PT provided is how much? PT provided is 100 into AST provided 706.85 divided by 1000 divided by D is 376. Fast answer. It will come in PT, no unit. PT answer. Some important concept is there now. PT 0.188. It is 0.188. Now do one thing. Refer IS code. Table number, I think table number 19, correct? I don't remember. I think tau C is 19, tau C max is 20. Tau C max is not required. Tau V, actually your tau V should not exceed tau C maximum. Leave it. It will never happen. Okay, no. Tau V is, see your tau V, you should write a note here, should not exceed tau C maximum. M25 concrete, tau C maximum is 3.1. Therefore, nothing to worry. But still right here, you should ensure that the tau V does not exceed tau C maximum. Okay, satisfied because tau C maximum is 3.1. Table 20. Table 19 correct? Table 19. Table 19 for M25 concrete. For M25 concrete, tell the answer. For PT and tau C. Tau C in Newton per mm square. We got 0.188. For 0.15 how much? For 0.25 how much? See, first they told less than or equal to 0.15 how much? Then for 0.25 how much? Tell me. M25 concrete for PT 0.15. Tau C. Bega. IS code. Recover IS code. Table 19. Fast. For PT equal to 0.15 tau C. 0.29. 0.29. And for 0.25 how much? For 0.25 how much? For 0.25 bega. 0.15 is 0.29. Don't give wrong values. 0.36. 0.36. Okay. Therefore, Tell me what happened here. For our PT equal to how much answer? 0.188. Tell me what is tau C? That is our allowed stress. Tau C, I told blue color. Why? Blue is good. Tau C, that is the allowed stress. Allowed shear stress. Start. By interpolation, get the value in Newton per mm square. What is the allowed shear stress? By interpolation. By linear interpolation, get me the allowed shear stress. 0.3166. Point. Blue color is good. ಈ 20 ಪೆನ್ ಆದರೆ ಹಿಂಗೆ ಆಗೋದು. ರೆಡ್ ಕಲರ್ ಇಟ್ಕೋತೀನಿ. ಇದು ಬ್ಲೂ ಕಲರ. ಒಂದು ನಿಮಿಷ. ಇದು ಬ್ಲೂ ಇರಬೇಕು. ಅಲ್ಲ ಇದಲ್ಲ, ಇದು ಬ್ಲೂ. 0.3166 Newton per mm square. This is the what? Allowed stress. Now do one thing. Compare your tau V with the tau C. See, very important. I think board should be visible now. I will check how much space is there. Because some statements are there now. I will see the board size. Okay, I can manage. Now make a note. Therefore, danger is what? Danger is tau V. Danger is tau V. Tau V is the actual stress. First of all, actual shear stress developed. I am telling 100 times, shear stress developed, which is found to be how much? 0.3693. And tau C is the allowed stress. Tau C is the allowed stress. Allowed stress sufficient. Allowed shear stress. It is 0.3166. Tell me, is it safe or unsafe? Fast. See, remember, your tau V should come less than tau C. You should make a note. Is it safe or unsafe? Fast. Not visible. Are you? Why? 1 minute now. Okay, I will slightly move the board. Okay. I will slightly move the board. 1 minute. I can't write once again now. I will move the board slightly. 1 minute. Okay. Okay, that side okay. Little further movement. I will make little further movement. Okay, now okay. Okay now. Okay. Tell the answer. So our conclusion is that actual shear stress coming is how much? Can't I get full board? Actual shear stress is 0.3693. Danger. Allowed is 0.3166. Therefore, tell me, safe or unsafe? Fast. Fast comment. Safe or unsafe? Unsafe. Somebody will tell. Remember, this is more than tau C or common sense. Stress coming is more, allowed less means unsafe. Bill is coming 3,693 rupees. In the pocket you have only 3,166 rupees. Ayyo, 500 rupees shortage. So therefore it is not safe. Danger. It is not safe. I want not safe. 1 minute now. Write a note. Suppose it is beam, no problem. Tell why. Suppose it's a beam problem, nothing to worry. Tell why. Tell me reason. Suppose this is a beam problem. In beam problem, tau A comes very high. No problem. Why? Reason. If it is a beam, there is no problem. Tell why. Fast. If same thing happens in a beam, nothing to worry. Reason. Fast reason. Why nothing to worry? If same thing happens in a beam, why nothing to worry? You can provide shear reinforcement. That's what you are doing. See, in beam usually, if it is 0.3, you get 1 something also. No problem. You provide shear reinforcement. But in foundation slab, when you provide a mesh of steel, tell me, have you seen for a not combined footing, when the beam type is there, I will come later, there shear reinforcement is given, not 2-legged, 8-legged, 10-legged like that. That we will discuss later. But have you practically seen a isolated footing where shear reinforcement this way? Have you seen stirrups being given for isolated footing? Have you seen? Practically. Stirrup means like this all. Have you seen stirrups provided for isolated footing? First. No. Because in case of isolated footing, stirrup providing is not possible. So what they do? They want stirrups not to be provided. Stirrups not to be provided means you should get shear reinforcement not required. Here, since your tau A is more than tau C, if it is a beam problem, shear reinforcement is required. It is not unsafe there. But if shear reinforcement is not provided, it is not safe. Why? Because stress coming is 0.3693, allowed for concrete is only 0.3166, not safe. So good thing happened. Now make a note. I told you earlier, punching shear is critical. Equally, this is critical. See, punching shear we passed. This failed. Sometime punching fails, this will pass. Both are like demons. Both are too dangerous in footing. One of them, punching shear, very dangerous. Second one, this shear. Both are equally dangerous. Both should be safe. So tell me why it came unsafe? Because I told you when you get the depth earlier, we increased by 75%. But I told you, instead of increasing 75%, practically everybody, once they get D for bending, they will not increase by 75%. I told you, they will take what? Tell me. I told you earlier, when they got around 300, I increased by around 280 came. I increased by 75%. But I told you, practically people will take not 75% more. How much I told they will take? I told you how much they will take. Usually people take what? Whatever requirement is there for bending, I told you, they usually take what? I told this answer for you. They usually take, I told you earlier, once you get the depth for bending long back, they take double, 100% more. So we took 75%. I deliberately took 75. Why? Because I want unsafe here. Why? In the class, if you get unsafe, you are learning. So right, getting unsafe in the class is good. Why? Then you know what to do. Practically no. Therefore, practically for this footing, not 450, I think people will take around 550 or 600 mm depth, 2 feet. Clear now? For this column, 850 kN load, they will tell Kannadalli 2 ಅಡಿ, Hindi 2 feet. They will tell, give a depth of 600, 450, 1.5 feet, that is around how much? 18 inches. No, they will tell 24 inches. Clear now? This I took lesser only to show you that unsafe will come. Clear or not? This concept. Clear or not? Clear. Now, what to do? Tell me, right here. What to do? Unsafe. right? What to do? Tell me. There are two options for you. One of the option, what? Tell me. One of the, you should write everything you are right. What all I am explaining, everything you are right. One, if becomes safe means good, leave it. You always learn when you get unsafe. Tell me. One of the option is increase what? Tell me. One of the option is increase. Which one? Increase depth. When you increase the depth, say 450 is not sufficient, maybe, see here, 0.36, 0.31, 3600, 3100. Maybe, tell the answer. Instead of 450, better, tell a number. Safer side, tell a number. Don't take too much more, tell a number. Don't waste too much. Proportionally, tell a number. 500 danger, illa. 500 risk is there. I can't tell. 475. Ayo, I told 500 risk is there, 475. Idyala kachara nimdu. What is this one? I told we are given 450. Overall depth. We are given overall depth 450. Better little more. 500 is risky. Tell how much? Say 550 or 600. If you higher depth, what will happen is, see, two benefits here. One, then you need not once again check for punching shear. Clear? People will laugh like anything. If you increase the depth, do not check once again punching shear. Punching shear effect will come further lesser. Tell me, clear or not? If you decrease the depth, then you have to check. If you increase the depth, you need not bother about punching shear. It will be over safe. Clear or not? Clear. And if you increase the depth, next time AST requirement, see, when you substitute mu equal to 0.87 equation, AST required will come slightly. What? Next time AST required will come slightly. AST required will come slightly. When you increase the depth, these all you have to write if you want. AST required will come slightly, fast, lesser. So, not too much lesser, little lesser. Instead of 12 tor 160, it may come 12 tor at 175. Means what? Little more spacing. Some people will tell, hey, let it be same. Safe or unsafe? They will tell, let it be same. Why bother? Requirement is going to be lesser, no. Steel requirement is going to be lesser. So spacing can be slightly increased. No problem. Provide safe. Clear or not clear? They may not bother. Clear? No. That they will ignore. You can ignore that one practically. Why? Because when you increase slightly, steel will decrease, they will ignore. They will tell okay. They will tell okay, provide same. Okay. But advantage, critical section will move further away or will come closer. Tell me, critical section will move further away from column or closer to column. Fast. Critical section will move further away or closer. It will move away. When the critical section moves away, shear force will decrease, your tau V will decrease. So it can come safe. Fully clear? Fast. Fully clear or not? So that is one of the option. Fast, clear. Okay. Now, second option is adjustment. Tell me, 1 minute. Adjustment. See, how much steel provided here? 12 tor 160 you have given steel. Okay. You can do one thing. See, your tau C depends on PT. You can increase the steel. When you increase the steel, your PT will increase. Therefore, your tau C also will increase. That is second option. And remember, that option you have to go when the difference is not too much more. See, 0.369, 0.317, okay, you can try. Not, suppose this is 0.6, that is 0.2. Oh, no, no. If you bill comes to 6,000 rupees, if you have got 2,000 rupees, adjustment is not possible. See, when adjustment is possible, you try. So, people usually go for second option. See, or one option you write, increasing D. Second option is, if Excel is there, it won't take much time. Second option will be increase steel. Increase steel. How? Tell me. Now you have to go for reverse interpolation. See now. Same way. Tell me. See now. Make a note here. We got all this you are right now. In the Excel what to do is nothing. I will tell you later. Excel what to do? Nothing. One number typing. See. Now increase steel. See how to increase steel. See. Tau we got how much? 0.3613. We want tau C also. How much? Tell me. Actual test is 0.3613. We want bill is 3,600. We want money also in the pocket, same. We want tau C also what? Tell me. We want tau C also how much? Tell me answer. How much tau C you want? For safety. Shear test came 0.3613. Earlier your allowed was 0.3166. Now we want allowed value how much? Tell me. We want tau C also how much? We want tau C also. If Excel is there, this is very, very easy. I will tell you later. Same problem, I will apply Excel for you next time. Next class, same problem, I will check the Excel. I will check your Excel with the same values. 0.36 what? 0.3693, that is, see now, I will tell you. Bill came 3,693 rupees. But in the pocket, we have only 3,166 rupees. So we want money in the pocket also 3,693. Therefore, go for reverse interpolation. Tell the answer. See. Now, M25 concrete, correct? Tell me answer. PT and tau C. PT and tau C. Tell me. Tau C I want 0.3693. Tau C is 0.36. If percentage is 0.25. Correct? Point. And if percentage is 0.5, tell tau C value. If percentage is 0.25, tau C is 0.36. If percentage is 0.5, tau C, fast. 0.49. 0.49. Therefore, now see, you have to come reverse interpolation. Therefore, for your tau C to be equal to 0.3693, tell what is the PT required? Fast. What is the PT required? Fast answer. Do reverse interpolation. You should stand here now. Nodi. You should stand here. Reverse interpolation. Not this way. For 0.36, 0.25, 0.4, 0.49, 0.5. To get here 0.3693, tell what is the PT required. Fast. Reverse interpolation. Fast. Make an answer. Interpolate in the reverse direction. Interpolate in the reverse direction. Later in Excel I will tell you. When the Excel is ready, it is very, very easy. 0.422 0.422. I don't know. You told 0.422. Check ಮಾಡಬೇಕಾ? ಮಾಡ್ಬಿಡ್ತೀರಿ. ರಿಸ್ಕ್ ಬೇಡ. 0.25. ಡಿವೈಡ್ ಬೈ ಎಲ್ಲಿದೆ ಅಯ್ಯೋ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಇಸ್ ನಾಟ್ ಆನ್. ವಾಟ್ ಇಸ್ ದಿಸ್ ಒನ್? ಆಯ್ತು ಬಿಡಿ, ಇನ್ನೊಂದು ಬಾರಿ ಮಾಡ್ತೀನಿ. ಪಾಯಿಂಟ್ ನನಗೆ ಬೇರೆ ವಾಳಿ ಬರ್ತಾ ಇದೆ. ಎತ್ಬಿಡ್ತೀವಿ ಕ್ಯಾಲ್ಕುಲೇಟರ್ನ. ಸಮ್ ಪ್ರಾಬ್ಲಮ್ ಇದೆ ಕ್ಯಾಲ್ಕುಲೇಟರ್. ಅಯ್ಯೋ, .479. ಈ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಪ್ರಾಬ್ಲಮ್ ಇದೆನೋ. there is some problem with the calculator. I want to throw it outside. I don't know why it is happening. Some numbers are jumping here. Here hinge ಬರ್ತಾ ಇದೆ. 0.25 divided by 0.49 minus 0.36. Okay, that much into bracket 0.3693 minus 0.36 equal to plus 0.25. 0.2679 ಬರ್ತಾ ಇದೆ ನನಗೆ. ಐ ಆಮ್ ಗೆಟಿಂಗ್ 0.2679. ನೀವು ತಪ್ಪು ಮಾಡಿದ್ದೀರಾ. ನನಗೆ ನೋಡಿ 0.2679 ಬರ್ತಾ ಇದೆ ನೋಡಿ. ಮತ್ತು ಯಾರು ಕೊಟ್ಟಿರೋದು ಫಸ್ಟ್ಗೆ 0.42 ಕೊಟ್ಟಿರೋದು ಯಾರು? ನಂಗೆ ಡೌಟ್ ಬಂತು. ಅವರೇ ಚೇಂಜ್ ಮಾಡಿಬಿಟ್ರು. ಡಿಡ್ ರಿವರ್ಸ್ ಆಯ್ತಾಯ್ತು. ನನಗೆ ಅನುಮಾನ ಬಂತು. ವೈ ಐ ಚೆಕ್, ನನಗೆ ಗೊತ್ತಾಗೋಯ್ತು ತಪ್ಪಾಗಿದೆ ಅಂತ. 0.2679 ಆಯ್ತು ಬಿಡಿ. ಇಟ್ ವಿಲ್ ಕಮ್ 0.2679. 2679. ನೌ ಡೂ ಒನ್ ಥಿಂಗ್. ಸ್ವಲ್ಪ ಜಾಗ ಇಲ್ಲ, ಇಲ್ಲಿ ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ತೀನಿ. ಪಿ ಟಿ, ಯುವರ್ ಪಿ ಟಿ ಈಕ್ವಲ್ ಟು 100 AST by BD. Therefore 0.2679 should be equal to 100 into AST divided by 1000 divided by D is 376. Therefore tell me what is the new AST. Tell me what is the new AST. Answer bega. What is the new AST? Your steel should change. You should provide bars closer now. Tell what is the new AST. Board ಕಾಣ್ತಾ ಇದೆಯಲ್ಲ, board visible. What is the new AST? ನ್ಯೂ AST ಆಗೋಯ್ತು, ಜಾಸ್ತಿ ಕೆಲಸ ಇಲ್ಲ. ನ್ಯೂ AST 0.2679 into 1000 into 376 by 100. ನ್ಯೂ AST 1007.3 1007.3 mm square. Therefore spacing for idea ಅನ್ಬೇಡ ಅಲ್ಲೇ ಬರೀ. ಫಾರ್ ವಿಚ್ ಆ ಸ್ಟೀಲ್ ಕೊಡಬೇಕು ಅಂದರೆ ಫಾರ್ ವಿಚ್ ಟೆಲ್ ದ ಸ್ಪೇಸಿಂಗ್ ಈಕ್ವಲ್ ಟು π/4 of 12 square divided by 1007.3 into 1000. Answer new spacing 12 tor 160 cancelled. Now new spacing how much? New spacing 12 tor 160 cancelled. New spacing, it should come closer now. You should give more steel. New spacing ಇವತ್ತೇ ಬೇಕಾಗಿತ್ತು, ನಾಳೆ ಅಲ್ಲ. ಏರಿಯಾ ಆಫ್ 1 bar by total area into 1000. 112.278. 112.278 is okay. Suppose spacing comes within 100, once again go back 16 tor. Okay. Therefore tell the answer. Provide what? Provide 12 tor at earlier steel cancelled. Tell me now new steel. ಬೋರ್ಡ್ ಕಾಣ್ತಾ ಇದೆಯಾ? ಒಂದು ನಿಮಿಷ, ಇದು ಡೌಟ್ ಬರ್ತಾ ಇದೆ. ಬೋರ್ಡ್ ಕಾಣ್ತಾ ಇದೆಯಲ್ಲ? Therefore provide 12 tor at, tell a spacing. 112 came, tell a spacing, round off. 112 came, round off, ಸ್ವಲ್ಪ ಕಮ್ಮಿ ಮಾಡಿ. 110 center to center. 12 tor at 110 millimeter center to center means slightly more steel. All right. Therefore, right here, for lengthwise bending, shear check over. It is made safe. It is made safe. You write there, first it came unsafe. One of the option is increase D, or second option is what? Increase the steel. Usually when marginal unsafe comes, people go for increase of steel. I will tell you later in Excel what to do. When you prepare the Excel, next time you have the Excel ready, this full board calculation, I will take a photo today. And because photo, or do one thing, you do one thing, my camera is there. You take a screenshot of this one now and send to my number. Take a screenshot of this one and send in the group or my personal number, send it. So that next time when Excel is ready, I will tell you how to use the Excel. This check for shear, which took nearly 1 hour to us, will take not more than 2 minutes. Will not take not more than 2 minutes. Okay, done. Take a screenshot, good screenshot, and send it to me. Clear now? Take a good screenshot and send it to me. Agreed or not? No answer. Take a screenshot and send it to me, so that next time I will see the screenshot values and tell how to type in the Excel. Instead of 1 hour, it will not take more than 2 minutes. This also, if you after practice, will not take more than 10 minutes. See, it may take around 10 minutes, but if you got an Excel sheet with you, it will not take more than 1 minute also. You are not answering. Okay, done. Now, lengthwise over, widthwise, you have to do it. ನೋಡಿ, start ಮಾಡ್ತೀನಿ. Now, ಇದೆಲ್ಲ ಸೇಮ್, ಎಲ್ಲ ಚೇಂಜ್ ಎಲ್ಲಿದೆ? ಕನ್ಸಿಡರ್, ನೋಡಿ, ಕಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಫುಲ್ ಯಾವ್ದು? I will take some good rest now. Why? Talking non-stop, I need rest. I do not know how to pause the live video. See, the problem is, in Zoom, I can pause. In recording, I can pause. But in live in YouTube, pause is there. I have seen so many people, institutes, they pause the video. But I do not know how to pause. If I try to do something, if the video ends, I have to make a new live stream. Therefore, I will not touch it. Display will be there for another 10 minutes as usual. Those of you who are feeling tired can take a break. But come in time. I won't tell when. I will suddenly come. So be ready. Now see. Consider, I will cut here. Widthwise bending. You should do it. Bending. Not front view. Go for side view. Side view. Same sketch. I should change now. Side view. That's all. My work is over if I go to side view. Then you should do it. Illi. Column is here. Column is here. Footing. Column here. Footing this way. You. ಇನ್ನು ಈ ಕಡೆ ಬರಲಿ, ಪರವಾಗಿಲ್ಲ. ನೋಡಿ, ಜಾಗ ಇದೆ, ಪರವಾಗಿಲ್ಲ. ಈ ಕಡೆ ಬರ. ಕಾಲಮ್ ಚಿಕ್ಕದು ದೊಡ್ಡದು, ನೋ ಪ್ರಾಬ್ಲಮ್. ನೋಡಿ, ಈ ಥರ. ಟೆಲ್ ಮಿ ನಾವು ಅಪ್ವರ್ಡ್ ಯು ಡಿ ಎಲ್ ಈ ಸೇಮ್. ಎಷ್ಟದು? ಡಬ್ಲ್ಯೂ ಪಿ ಸೇಮ್. ಎಷ್ಟು ಆನ್ಸರ್ ಅದು? 154.545 ಕಿಲೋ ನ್ಯೂಟನ್ ಪರ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಓನ್ಲಿ. ಟೆಲ್ ಮಿ what is this projection and what is this projection? They get the answer. What are these two projection? Or I will do one thing. Tell me, what is this projection and what is this projection? Bega. Widthwise projection. Answer. Bega beku. What are the widthwise projection? Don't waste time. You are wasting lot of time by not giving answer. 0.985 lengthwise ಎಷ್ಟಿತ್ತು ಕರೆಕ್ಟಾ 2.2 minus 0.23 divided by 2 0.985 widthwise projections are 0.985 almost equal 985 critical section comes here ನೋಡಿ critical section from here is at D equal to 0.376 therefore tell me what is this length bega what is this length 0.985 minus 0.376 XL I will tell you 0.985 minus 0.376 how much 0.609 therefore shear force one more section is here at critical section equal to 154.545 into 0.599 alla ettu 0.609 tell me clear or not it is not 0.599 it is 0.609 tell me clear or not fast it is not 0.599 0.609 you tell clear I will work out clear okay now this value will change the value same way remember 12 torr not 160 tell how much tell me widthwise bending we decided 12 torr tell me at what spacing not 160 tell the answer widthwise bending we decided 12 torr at not 160 how much we decided 12 torr 150 remember widthwise steel we decided 12 torr 150 now take your calculator take a rough sheet now and perform the calculation after the class is over make full fair copy because I will come here and change the numbers at that time don't waste time if it becomes unsafe increase the steel there also you complete the widthwise bending check in the same way as lengthwise bending till you get safe tell me agreed or not agreed I may take around 10 minutes break now see 7:20 is the time now it is 7:20 shall I come at 7:30 shall I continue at 7:30 that is nearly exact time now is 7:18 okay 12 minutes break shall I continue exact 7:30 okay for up to 7:30 screen will be there with no activity correctly all those who are leaving for break now exactly come back at 7:30 okay over but when I come should not waste time in the 12 minutes time now take a rough sheet see the display and get all the values you are agreeing later when I ask you you will not tell usual see when I take some other classes you don't know when I go there value starts coming there people do seriously I don't know why you are not doing it they do it seriously sometimes before I settle for break they will tell everything is over but these people you people are not showing that much interest okay I'll restart exact 7:30 I'll remove that charging because it is showing overheating and if the charging level is above 60 it will come up to 9 o'clock no problem I will check it otherwise I will put charging once again oh charging level is 60 so no problem I can remove the charger I can remove the charge remote safer side at around 8:30 remind me for charging agreed safer side at around 8:30 remind me for charging okay at 8:30 can you remind me in a message box I will check the charging there if it is below 30 or 20 I will again charge it now okay don't forget otherwise Suddenly it will go. Okay, more probably, okay, I think. Okay, done. Now start. Show your talent and get the value. See, already 2, 3 disappeared. Why? Break means all are happy. You should correctly solve and get the answer. Check the charging. Charging is 53 now. I think okay. Because it gives overheating. Or I put the charging on. Remind me after half an hour to remove it. That is better. Otherwise, if you forget and I also forget, suddenly it gets switched off then. Who will take the chances? I am very good in forgetting these things. Actually, I am expert in forgetting. Except structure engineering. Everything, within no time I forget. Here, Martia. Okay. After charging on, you can do one thing. It is showing around 50. At 8 o'clock, you can remind me to remove it. Why? I do not want overheating. Because in summer only it happens. In winter that problem is not there. Because very hot weather, charging and live both means it gets heated. So remind me at around after half an hour. I will remove, then nothing to worry. Further 1 hour it will come. There is no problem. It will come for further 1 hour, I am sure. Okay, now start. Fast tell the answer. Fast tell the answer. Shear pose, how much? Don't waste time now. Shear pose. Don't waste time now. Shear pose. Shear pose, how much? Before that, board is fully clear and voice also clear. Board and voice, both are okay. Display and voice, both are okay. No. Display and voice, both are okay. Fast. Clear. Okay, tell me. I will do one thing now. If you tell, I will correct it. The pen problem. Etado 94 point, I will use green color. 117. Okay. Factored value. How much? Factored value. Factored value into 1.5. Change it. You should do the changes. You should make a fair copy. 141.2. Okay. Then shear stress. 141.2 10 to the power 3 answer. Bega. Shear stress. What is shear stress coming? 141.2 10 to the power 3 by area. 0.3754. 0.3754. And to get allowed value, steel is not 150, 12 tor at 150. Therefore, you should write here 150 here. If you make it 150 here, tell the AST. AST will change. Excel I will tell you. How to do in Excel I will tell. If Excel is there, nothing. 1 minute, that's all. Today I will give instruction for Excel. Next time you prepare the Excel and tell me. 753.98. Okay. Then if I write 753.98 percentage, fast. Percentage. 0.2005. 0.2005. If percent now, yes, correct. For PT equal to 0.2005 tau C. Tau C answer. Interpolation. Tau C. .3254. 0.3254. Therefore, here also tau V is 0.3754. 3754. Tau C is 0.3254. Therefore, here also unsafe. Same note. We want to get tau C, how much? 0.3754. Okay. Now, reverse interpolate. This time for tau C to be 0.3754, do reverse interpolation and tell me PT required. Fast. To get tau C 0.3754, do reverse interpolation and get how much answer? 0.27 ಸುಳ್ಳು ಹೇಳ್ಬಾರ್ದು 0.2796. If it is 0.2796, area of steel required, how much? New area of steel required. If it is 0.2796, area of steel required 1051.35. For which spacing? 1051.35 spacing. 107 point how much? 573. You can provide 12 tor at 107 km, say 100 centered center. Clear? Provide 12 tor at 100 centered center. Clear now? Okay. Now do one thing. Further checks are there. This question I am not telling because this is only a demo question. Remember, design of footing, actually there is a check for bearing pressure check is there. Here I will not do because reason is there. This question, column subjected to only axial load, the purpose is to understand all the concept of footing, like bend, lengthwise bending, widthwise bending, then punching shear, how it comes, and how to find steel here, how to find steel for this bending, how to check for one-way shear here, how to check for one-way shear other way. The purpose is to understand the basic concept. Practically, this type of design of footing will never come. I will guarantee. When you do design of footing for an ordinary building, small residential building, then you may get it. Then the bending moments are coming very small. Then you can do this way. But then actually, sometimes people won't design. Ground plus 2 means they will simply provide the footing. You ask, Mestri will tell. You don't believe them. So, when you are in the serious structural design business, or not business actually, serious structural design field, every column when you design every column and every footing, column will be subjected to axial load with biaxial bending already over, and footing also axial load with biaxial bending. So P, M1, M2 will come. That is our next question. So our next part is design of isolated footing. When from column you have to consider not only axial load but M1, M2. When earthquake is there, high M1, M2 is going to come. Remember, when you consider earthquake, high values are coming. So next question is practically important. But next time, I don't have to waste time on telling, see lengthwise bending, that all already cleared. So now there, your pressure will not be UDL. It will be varying linearly. Pressure will not be linear. That I will tell you. Therefore, this is taken care. Just to understand, you just write a sketch here. The sketch means not too much. See, one light sketch. How practically you give. Red I will write, no space here. Red color came, I use red color. Okay, right here. This is 2500. Why? Usually in the final drawing, always write millimeter. 2200. Column comes here. This way. Column comes. That actually not required. 230 by 550. You show, see this is lengthwise steel. So many bars will come, not required. You show just one bar. That's all. If you show one bar, bar bender will not put one bar. He knows it. So you write here, and here also show one bar. This bar you write 12 tor at lengthwise bending, 110 center to center. This is 12 tor at 100 center to center. And somewhere here you have to write thickness of slab. You write 450 thick, because in the plan thickness cannot be seen. You write 450 thick. That's all in the drawing. Clear now? That's all you send to site. But still, if you want to understand, actually not required. Practically, that's all. If this is drawing sent to site, they will prepare the reinforcement and concreting. Clear now? Yes, you don't require. But still, for your understanding, if I take a section here, what you can see? You can see column and footing like this. Column side you are seeing is 550. Footing thickness is 450. You put lengthwise bar here, say 12 tor at 110 center to center, widthwise steel. Okay, place above, no problem. You can see this way dot, that is 12 tor at 100 center to center. And column bars will be there, that will come and rest here. And then also stirrups will be there, show it. Okay, now, or you take a cut here, look from side here. You can write this way only. Okay, I write here. You can see like this. Just to understand, you can turn and write. Actually, practically, sections are not required. Now you are seeing column of only 230 mm. And you can see one steel here. Thickness is 450. This steel is 12 tor. This is the widthwise steel. 12 tor at what spacing? 12 tor at 100 spacing. And lengthwise bar, see there, it is below the steel. So you can see like this. Dot. This is 12 tor at 100 center to center. Below this one you have to show bed concrete all. PCC all you have to show. That I am not wasting time. Roughly, sketch clear? Tell me. That's all. Only this sketch is sent to site. These sketches are not sent. Clear now? And one more thing. By chance, you go for a bad footing due to space problem. When one projection is more, one projection is lesser, then you can insist there. Put higher diameter you can give for higher projection side, lesser diameter, then you can tell in the site, place first the higher diameter bar for a lengthwise projection, then you can tell them place widthwise, then one sketch you have to show there. Or field instructions, you can write a note there, first place bars for lengthwise or widthwise, depending on the requirement. But design point of view, we have taken same D. So if they interchange, nothing will happen. Okay. Now, I will go for the important part now. That is what? See, make a note here. Make a note. Design, when you design by software, that is SAFE, ETABS&SAFE, you are importing the load, etc. from the ETAB. Therefore, you don't have to apply the load. One. Second, all load combination there will come here also. ETAB will design for critical case. Next, in the ETAB, length and width, L1, L2, you have to decide. How? For that, sometimes by practical knowledge, people are able to do it. But till you get the grip, what you can do is, you can use a Excel. That Excel I cannot tell today because, tell me why? Because practical design, when you prepare Excel for deciding L1, L2, I told you here, last time calculation, equate the projections all. But practical design, you are getting not only P, but with M1, M2. So that Excel I can explain only after I cover pressure calculation when column is transferring P, M1 and M2. Okay, one. Second point. Slab thickness you randomly give, because if unsafe, you changing will take few seconds. You try 400. It will tell not safe. 450. Not safe. 500. Safe. Over. So changing thickness is not a main issue. You change the property, you go to property, there define. I forgot almost now ETAB, which button is where. I have to at least practice one day because almost forgotten now. But no problem, I will remember. I will not forget. Sometime before starting the software, I will just go through one day, I will sit there and see where is the, sometime their lines will come. To remove the line, some procedure is there. I forgot. Nothing to worry. That all secondary. I will not forget M1, M2 like that. Then, what you do is, what I told just now. Thickness changing, you go to property page, change the thickness, done, over. And check for punching shear, you don't have to worry. Why? ETABS&SAFE will take care. Or I will tell you in top, ETABS&SAFE, I will tell software will take care, over. Now, check for our wide beam shear or shear causing diagonal tension. That check you have to do. When I was using the software earlier, it was not there. Anybody know any recent version? Who knows? It is possible that they made a modification. See, I was using earlier 2010 model, that version. Now, anybody can tell latest version? Latest version. Even I am not bothered. I will bother just a week before I am going to ETABS. I will bother just a week before going to ETABS. Why should I bother now? Anybody can tell what is the recent version of ETABS available? Recent version. Recent version of ETABS. Anybody know? Nobody got idea. I have to inquire. Nobody knows. Recent version. Why? No answer. You tell don't know if you don't know. 19, okay. I don't know. See, I will prepare the Excel sheet now. It is possible that suddenly when I open there, check for wide beam shear, they might have incorporated. If they incorporated, thank you. So our effort is wasted, but actually not wasted. Why? You will learn once again. But 99% I am sure they are not bothered. Maybe they decided, check for the shear, you only do it. You are a structural engineer. I am giving you so much of design part. You are building entire building, I will design in split second or 2-3 seconds. See, it will actually once flash this way and give the answer. 2-3 seconds I am giving design, which you may take 2-3 decades if you do manually. Therefore, you are charging fees for clients. Therefore, check for two-way wide beam shear, you only do it. Most probably, ETAB will not do it. I know. Anyway, I will ask it. Today night I will ask those who are using new version. I will ask them, is that check for shear included or not there? I will ask a competent person. Otherwise, I ask randomly, sir, check for shear. Yes, sir, people are there. They are called expert designers. Chakka. See, people are there. Therefore, we will prepare. Why? I know it is not there. So remember now. Therefore, today I will give instructions to prepare Excel sheet for checking for one-way shear, not punching shear. One-way shear. At least during weekdays, you prepare and send in the group. But last one is correct. I checked it. So, but you do one thing. I will tell you how to check it. Today's example, use it for checking. Use today's example for checking. Clear now? Use today's example for checking. Second check I will do. Use today's example for checking it. Clear or not? I will tell you how to create the Excel sheet. Okay, see now. Title, right? Title. Check for one-way shear. One-way shear for footing. For isolated footing. That is important. Isolated footing. not for combined footing. Or you can write that is wide beam shear or shear causing diagonal tension, or that shear which is not checked by software. ಏನು ಬೇಕಾದ್ರೆ ಏನೋ ಹೆಸರು ಹಾಕ್ಕೊಳ್ಳಿ, ಪರವಾಗಿಲ್ಲ. ವಾಟ್ ಎವರ್ ನೇಮ್ ಯು ವಾಂಟ್, ಟೈಟಲ್, ಸ್ಟಾರ್ಟ್. ಇನ್ಪುಟ್ ನೋಡಿ, ಇನ್ಪುಟ್. We should prepare so that input we can get from SAFE. See, first you tell capital D, tell the answer, highlight black, input capital D. See, blue color values you require input, red color value you don't, you hide it, it is not required. When which I write red color, it is, there is no input, you completely hide it. Okay. Input D, tell me today's class D to test. So now one thing, now see right here, imagine I will give input based on lengthwise bending of today's example. Lengthwise bending of today's example. I will give input based on lengthwise bending of today's example. Tell the answer. Input, how much? Input. Answer, input. 450 mm input. See, green color, blue color means you have to give input. Input I will put black. Okay. Input D over. Don't give breadth input. Then you tell FCK input required. Tell FCK input. You can change the order later. You can change the order later. FCK input. Answer fast. FCK input today 25. This is in millimeter. Okay. FCK in D input in millimeter. FCK input also in Newton per mm square. 25 over. FCK is clear. Then see, if you do manual calculation, tell what you have to do. Then what I want to tell is, if you do manual calculation, you have to consider a critical section at D from face of the column. 1 minute now. Now you require D. Then you tell bar diameter. Tell the answer. Bar diameter. Today's input. Answer. For this question, input. How much? Bar diameter. To be safer side, higher value. But in the Excel you can use actual. Excel you can use actual. How much? 16. Actually not 16. If you want, you can write 12 also. Why? Once you decide 12, you can type 12 also. Okay, 16. Then over. You tell the Excel that, now red color. Sorry. You tell the Excel that, sorry, red color now. Don't show, let it be hiding. You tell the Excel, this is in millimeter, forgot. Bar diameter in millimeter. Okay, then tell the Excel, your D in millimeter equal to whatever is capital D minus 50 clear cover minus, or you can write clear, okay, don't think. Type clear cover also. Type 50. Why? Sometimes possible that due to waterlogged area, clear cover may be more. So input clear cover also. You tell 50 minus clear cover minus dia by 2 minus dia of bar by 2. Tell me, how much Excel will take now? Answer. See, this is red color. You should not allow anybody to use it. Red color. Tell the answer. I will round off with the red, which is not to be used. Tell me, how much D Excel will take? It will take 376. Okay. 376 will take. Okay. Now remember, this is not input. This Excel will take care. Okay. Next. If you are doing manual calculation, you move by distance D, see the pressure value, and then find the shear force, and then without forgetting multiply by load factor and get the factored shear force. Tell yes or no. Finally you get VU if you are doing manual design? Yes or no? Fast. You move by, you mark critical section at D from face of the column, then see the cantilever action and look the other side, and then find shear force. First find shear force working load, then multiply by load factor, get factor shear force. Yes. When you use Excel, when you use software, not that way. Direct input of VU. VU input you give in kilonewton. Okay. See now. Direct input. How? How means when you go to software, you'll be knowing. I will tell you the software class. Take the cursor. Go to result sheet. SFD, BMD, you have to go. You have to go there, and I will tell you, move the cursor by what distance? Tell me. From the face of the column, I will tell, move the cursor by what distance? Tell me. Move the cursor by what distance? First. Move the cursor by distance D. Stop. Actually, 0.376 meter. But actually, very, very difficult, because you touch it, it will fluctuate like anything. Slow, steady hands required. Okay, instead of 0.376, little this side, that side, no problem. No, anyway, or safer side, 0.375 also will do, but should not go beyond. Move the cursor. That's all. Your software will directly tell you what? Tell me. Software will directly tell you what? Software will directly tell you. Tell me what? Software will directly tell you. Which one? Software will directly tell you. You don't have to calculate anything. It will tell you VU value. But one thing, you should activate what? Factored value there. Not working load value. Result sheet, when you go, you should go for factored value. Okay, clear? Or it will give the worst, it will, among the different combination, you can still ask it to give the worst value. So this is directly. See, directly take or get by software. How? Software. How? In the ETABS&SAFE, when I finish all beams, columns, slabs, and then what? When I tell first control of ETABS, how to control, how are the load assignment, so many things are there in ETABS to learn. Remember, when I teach ETABS, I will make perfect, not randomly tell a loading and tell, okay, do. See now, I will tell it more clearly than RCC part. Not randomly do something. If I take something, I go for perfection. Everything you will tell. I will tell you parallelly, you also operate if requirement is there. But sometime I will tell you, do not do parallelly, because if you do parallelly, you are busy operating what? Your laptop. What all I am telling, you will not follow. So I will insist everybody, do not try parallelly unless you got control. Listen correctly what I am doing. I will be somewhere there. In the table, laptop will be there. You can see the laptop in your Zoom screen. It will not be in YouTube. It will not be in YouTube class. It will be Zoom class, our original class. In the Zoom class, in the Zoom window, you can see the laptop. Microphone is with me. I will ask you, when you tell the answer, I will come and enter there. Once in a while, I may have to come here, but I cannot keep on coming here and there. So what I will do is, after a stage, I will remove that sharing screen, I will focus on the board, and then I will tell you in between. See, I told you that way, make a note. I cannot see earlier, when I was operating offline, I used to use this projector. There, half the screen I will use projector, remaining half the board I used to write. So light will come. So When I am using projector, I will go and sit there in front of them. They will tell. When I want to explain here, I will come here. Here I can't do that way. Once screen sharing, once board, not possible. Some adjustment I will make it. Or maybe I may have to make double meeting. That also will do. Parallelly, one more, is it possible? Possible. That also I have to think. Possible. You have to log in 2 times. One for your laptop display, one for your board display. Then see, laptop display will come, board is empty. I will have 2 tripods here. In one of the tripod, I will go, whenever I want board, I will come there. Both will be on. I will think of alternative for that one. But don't worry, I will make offline in online class more effective than offline. Okay, now, how to get it? You get in the software. So, today's example, tell me, for lengthwise bending, you type how much today? Tell me, how much you have type? You don't calculate. When you do by Excel, VU comes directly in Excel. Sorry, Excel Allah, software. Tell me, today's example, checking purpose, directly type VU in kilonewton. How much? Yesterday? Charging remove. Okay. I remove the charging. I remove it. It mugili. Tell me, lengthwise bending, factored shear force. Tell, because when you go for software, you don't have to factor. Software will factor and tell the answer. Answer 138.86 you type. You type this number, correct? This typing. Okay, now see, next step. You tell the Excel, directly tell it tau V equal to VU by BD. Red color. Why red color? Tell me. Why red color? No input. You tell the Excel tau V equal to VU by BD. Wrong. Tell me why. If you do this way, VU is in kilonewton. Tell the Excel what? Tau V equal to, we want tau V in Newton per mm square. Therefore, in the Excel sheet, you have to write tau V equal to not VU. What you have to write? You should be careful. What you have to do? Not VU. Your VU typed is 138.86. What you have to tell it? VU into 10 to the power 3. Okay. Remember, full red color. Over. Tau V came. Then tell the Excel to get PT provided. No, don't worry. You tell the Excel what is the spacing provided. Spacing provided. See, diameter of bar already told. What is the spacing provided? So, diameter, you should not tell 16 now. Tell how much you have type. You should not type 16. See, because your steel required. You should not type 16. Tell how much you have type now. No, see, if you type 16, wrong. How much you have type? In the Excel, actual provided. How much you have type? You should type 12. If you type 16, wrong, 12. And then your D will not come 376. It will come little more. Excel will take it. Okay. Now, spacing provided equal to, for diameter I told. Tell the answer. Spacing provided. How much? How much you have type now? Tell me. How much you have type for lengthwise bending? For spacing provided. Final spacing provided. You should do it in the beginning only. The final spacing provided. But no, before the check for shear. Before the check for shear. Before the check for shear, spacing provided. Not after check for shear. Later you decrease the spacing. I think it is 160, I think, most probably. Correct? I think 12 or 160, I think. 160. Tell 160 millimeter. Over. Then tell the Excel directly PT equal to what? 100 into AST provided is what? Is 1000 divided by the spacing into pi by 4 of diameter square divided by 1000 divided by d. Correct now? 100 into AST provided is width B by spacing into area of 1 bar by BD. Single step. Tell the Excel what is the PT value. Red color. Why tell me? You are not inputting, going to input. Excel will calculate. Tell me. Excel will take this PT as how much? Not our class value, because you are going for 12th or slight change will come. Okay. We will do next time. It will take the value of PT. Tell how much? Approximately PT. How much you got PT first time? It will come slightly what? Lesser. PT. How much you got first time? Minute change. No problem. Exact, because 0.188. It won't take 0.188. Minute change. Okay, no problem. Okay. But you don't calculate. Okay, now for this PT, tell me what you want. For this PT, tell me what you want. For this PT, you tell the Excel to get what value? For this PT, you tell the Excel to get. For this PT, you tell the Excel to get tau C value. Tell me to get tau C. To get tau C, red color, for above PT. What the problem? By this, Excel should calculate. Excel should calculate. You are not calculating. Excel should calculate. Oh, problem. Tell me, why problem? Why problem? Why problem? Tell me. Why problem? Why problem? Problem. Why? Fast. Why problem? Why problem? There is a problem now. Nothing to worry. Every problem has solution. What is the problem? Linear interpolation. How? Excel does not know table 19. Excel does not know table 19. So, you cannot give interpolation because you got 0.188. Tomorrow it can come. Then you have to interpolate between 0.15 and 0.25. If it comes to 0.273, interpolate from 0.25 to 0.5. If you get like 514, interpolate from 0.5 to 0.75. If you got 0.786, interpolate from 0.75 to 1. Based on different grade of concrete. What to do? You cannot feed that table to Excel. Therefore, I will tell you, one of the option is what? Ask the Excel to type this PT value. It will show you PT. Then you have to take your calculator right there. You ask the Excel, you tell me PT value. Okay, Excel will display PT value. Then you take your calculator, use IS code, see the IS code, based on that PT by interpolation, get what value? Based on PT by interpolation, get what value? Based on PT by interpolation, get what value? Based on PT, get tau C and enter it. But it will take time. No, not required, because make a note. In our class up to today, right? In our class up to today, that is 8:13 p.m. on 03/04/2022. We used table 19 to get tau C based on PT. Tell me, yes or no? We used table 19 to get tau C based on PT. Tell yes or no? Fast. Up to today, 8:13 p.m. Yes. ಆದರೆ but this if you use for Excel, you have to again do the calculation. Nothing to worry because I will tell you now. This I will remove now. I will remove this one now. Not required. But actually, ನಿಜವಾಗಿ ಹೇಳೋಂಗಿದ್ರೆ ನಥಿಂಗ್ ಟು ವರಿ ಇನ್ SP16 expression or you can call equation is given to get tau c based on PT. Oh, actually remember IS code prepared that tau c table using this expression only. Remember, like modification factor, IS code has given figure number 4, but actually it has got a formula 1/0.225 plus 0.0032 into Fs plus 0.625 log to the base 10 of PT. Remember or not? IS code has given graph, but I told you it is available. Yes, it is not in SP16. Somewhere else it is there. Somebody told me, I was not knowing earlier. Sir, ಈ ಥರ IS ಪಬ್ಲಿಕೇಶನಲ್ಲಿ ಕನ್ನಡದಲ್ಲಿ ಸರ್ ಅವರು MFಗೆ ಇಕ್ವೇಷನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಕಳಿಸಿ ಹಿಂದೆ ಕಳಿಸಿದ್ರು. ಐ ಚೆಕ್ಡ್ ಇಟ್, ಕರೆಕ್ಟ್ ಆಗಿದೆ. ಓಕೆ, ಡನ್. ಸೇಮ್ ವೇ ಇನ್ SP16 equation is given to get tau c based on PT. So according to SP16, from that equation only what? From that equation only IS code prepared. Remember, directly tau c equal to 1 ನಿಮಿಷ. I do not remember. I need SP16. 1 ನಿಮಿಷ. Where is it? Main problem now. I need SP16 now. 1 minute. It will be somewhere here. I will check it. Hold for 1 minute. And see the equation. Every chance that it is somewhere here. SP16, where are you? I have requested. Or one of you open SP16. Have you got it? I think here what happened is all are randomly scattered. Ever you sometime when I set the screen, you have seen how things are scattered here. Sorry, I got it. Okay, now I will remove the charger. Oh, now charge is it is 50 ಇದೆ, ಸಾಕು ಬಿಡಿ. ಬೈ ಚಾರ್ಜ್ ಗೋಸ್ ಆಫ್ ಮೀನ್ಸ್ ನೋ ಪ್ರಾಬ್ಲಮ್, ಇರಲಿ ಬಿಡಿ. ನೋಡೋಣ, 50 ಚಾರ್ಜ್ ಸಾಕಾಗತ್ತೆ. ಓಪನ್ ಯುವರ್ SP16. ಓಪನ್ ಮಾಡಿ. ಓಪನ್ ಯುವರ್ SP16. ನೋಡಿ, ಗೋ ಟು ಲಿಮಿಟ್ ಸ್ಟೇಟ್ ಮೆಥಡ್. ನೋಡಿ, ಲಿಮಿಟ್ ಸ್ಟೇಟ್ ಮೆಥಡ್. ಐ ವಿಲ್ ಟೆಲ್ ಯು, ಸ್ಟಾರ್ಟಿಂಗ್ ಈಸ್ ಲಿಮಿಟ್ ಸ್ಟೇಟ್ ಮೆಥಡ್. ಗೋ ಟು ಶಿಯರ್. ಎಲ್ಲಪ್ಪ ಶಿಯರ್ ಇಲ್ಲೆಲ್ಲ ಬಿದ್ದಿರುತ್ತೆ. ಇಲ್ಲ ದಿತ್ತು ಶಿಯರ್. ಶಿಯರ್ ದೇರ್ is a problem. See, page number 175. There is a serious problem now. Nothing can be done. Not a problem. Page number 175. Those who are having SP16, go to SP16, go to page number 178. Got it or not? Tell me. There's a reason. Got it or not? Got it or not? Tell me. Page number 178. Fast. If you are having yes. SP16. Okay, now unfortunately what happened there is, see, I will show my SP16. There is a ink mark here. One day when I was keeping there, ink bottle fell on that one. Something happened. So the equation is partially blurred, but somewhere in the corner I copied. I don't know. You should check your SP16 and tell me correct or not, because here not visible. What happened here is, see there, because of the ink spreading, I cannot see. I will write the equation. You check your SP16 and tell me correct or not. 0.85 into root of 0.8 FCK, ಇದು ಯಾರಪ್ಪ ಮಹಾನುಭಾವ ಮಾಡೋದು, FCK into bracket square root of 1 plus 5 times beta, then minus 1 is outside bracket, outside root, minus 1, because someone told, sir, bracket ಒಳಗಡೆ ಅಂದರೆ ಏನು ಲೂಸ್ಗಳವರು, 1 minus 1 ಯಾರು ಬರೀತಾರಾ? Is it possible somebody puts 1 plus 8 minus 1? It is outside the root. Minus 1 divided by 6 times beta. Divided by 6 times beta. Now, beta value should be where beta equal to 0.8 FCK divided by 6.89 PT, where they told PT equal to 100 AST provided by BD, and they told condition value of tau c beta should not be less than 1. Beta should not be taken less than 1 is a condition. Tell me, did I write correctly? Did I write correctly or not? I don't know. Here, because of ink mark, I cannot see. Because of ink mark, I cannot see properly. Did I write correctly? Check fast. I do not want to make mistake. Correct? Okay. Therefore, nodi. Therefore, in the Excel sheet, what to do? Tell me. See, Excel by this time knows what value? Excel by this time knows FCK. ಅದು ಗೊತ್ತು. ಆಮೇಲೆ Excel also knows what is PT. Also, Excel also knows what is PT. Tell yes or no. By this time, your input, Excel knows what is FCK and what is PT. Tell yes or no. Excel should know it. You cannot tell Excel, ಅದು ಅಲ್ಲಿದೆ ಅಂತ. No. In the Excel, everything should be known. If something is there in the equation, you should write the equation after clarifying all terms. Tell me yes or no. Tell me. By this time, for our first question, our lengthwise bending, Excel knows that FCK is 25 and PT is, tell PT. Tell what is PT for our first question or lengthwise bending. By this time, Excel knows FCK 25 and PT ಎಷ್ಟು ಪಾಯಿಂಟ್ ಎಷ್ಟು ಹೇಳಿದ್ರಲ್ಲ, ಎಷ್ಟು ಹೇಳಿದಾಗ ನೀವು ಪಾಯಿಂಟ್ ಎಷ್ಟೋ ವ್ಯಾಲ್ಯೂ ಹೇಳಿದಾಗ PT ಎಷ್ಟೊಂದು ವ್ಯಾಲ್ಯೂ ಹೇಳಿದ್ರಿ PT ಆಗ ಇಷ್ಟೊತ್ತು ಬೇಕಾ? 0.188. Excel knows this one, correct? Okay, that's all. Now in the Excel you should not write equation for tau c. Before equation for tau c, hidden. You should write, you should tell Excel how to find what value. Tell me. You should not tell the Excel tau c equation now. Before you Excel already knows FCK and PT. So therefore you should not tell the Excel equation for tau c. It will not calculate. What you have to do? Before writing equation for tau c, you should tell the Excel that what? How to calculate what value? Tell me. How to calculate beta? You tell the Excel, ready? Before you put a heading to get tau c, tell the Excel to get beta. You tell beta equal to 0.8 FCK divided by 6.89 PT. Clear? Tell me, how much Excel will take this value? Tell me. If you write this equation, Excel knows FCK, Excel knows PT. How much Excel will calculate this value? Fast answer. How much is the value which Excel will calculate for this value? Bega, bega. How much value Excel will take for this one? Ittottu beka? 15.4402. ಯಾರು 15.4402 ಅಬ್ಬಬ್ಬಾ ಬೀಟಾ 15 ಪಾಯಿಂಟ್ ಏನೋ ತಪ್ಪಾಯ್ತಾ? ಯಾಕೋ ಡೌಟ್ ಬರ್ತಾ ಇದೆ ನನಗೆ. ಆ ಥರನಾ? ಬೀಟಾ ಈಕ್ವಲ್ ಟು 0.8 FCK ಬೈ 6.89. ಅಯ್ಯೋ ಗ್ರಾಚಾರನೇ. ಎಷ್ಟು ಹೇಳಿ ನೀವು? ಅದೆಲ್ಲರೂ ಪಿ ಟಿ ಮೇಲೆ ಇದೆಯಾ ಕೆಳಗಡೆ ಇದೆಯಾ? ಇವ್ರು ಸರಿಯಾಗಿ ಪ್ರಿಂಟ್ ಹೊಡೆದಿಲ್ಲ. 0.8 FCK ಬೈ 6.89 PT. ನನಗೆ ಯಾಕೋ ಡೌಟ್ ಬರ್ತಾ ಇದೆ. ಓಕೆ ಬಿಡಿ. ಇಟ್ ವಿಲ್ ಟೇಕ್ ಎಷ್ಟು? 15.4402. ಆಯ್ತು ಬಿಡಿ. ಇಟ್ ವಿಲ್ ಟೇಕ್ ದಿಸ್ ವ್ಯಾಲ್ಯೂ ಆಸ್ 15.4402. Then you tell the Excel, condition is that beta should not be taken less than 1. ಯಾಕೋ ಡೌಟ್ ಬರ್ತಾ ಇದೆ ನನಗೆ. 15.4402 ಯಾಕೋ ನನಗೆ ಡೌಟು. ಈ ಪಿ ಟಿ ಇಲ್ಲಿದೆಯೋ ಅಂತ. ಅವ್ರು ಕೊಟ್ಟಿರೋದು ಏನು ಗೊತ್ತಾ? 0.8 FCK ಸ್ಲ್ಯಾಶ್ 6.89 PT ಇಂದಿದ್ದಾರೆ. ಯಾರು ಗೊತ್ತು? ಇದು ಇಂಟು ಇರ್ಬೋದು. ಅವರು ಸರಿಯಾಗಿ ಕೆಲವರು IS code has not maintained. It is their mistake. I will check it now. We will check it now. I don't know. If they want this way, if they got mathematical sense, they should have given this way. By giving this way, our type ಮಾಡೋದು ಈ ಥರ. If somebody types this way, ಈ ಥರ ಟೈಪ್ ಮಾಡಿದ್ರೆ ಅದರ ಅರ್ಥ ಏನು? ದಿಸ್ ಬೋತ್ ವಿಲ್ ಕಮ್ ಇನ್ ಡಿನಾಮಿನೇಟರ್. ನನಗೆ ಯಾಕೋ ಡೌಟ್ ಬರ್ತಾ ಇದೆ. ಆಯ್ತು ನೋಡಿಬಿಡಿ, ಚೆಕ್ ಮಾಡೋಣ. ಈಗ ಗೊತ್ತಾಗತ್ತೆ. ಈಗ ಗೊತ್ತಾಗತ್ತೆ. ಟೆಲ್ ಮಿ, ದಿಸ್ ಈಸ್ ಬೀಟಾ. ಓಕೆ, ಇಟ್ ವಿಲ್ ಟೇಕ್ 15.4402. ಬಟ್ IS code told beta should not be taken less than 1. So immediately you have to put a command. What? You have to tell the Excel. Tell the Excel that what? If beta is less than 1, then take beta equal to how much? Tell me. You tell the Excel, if beta is less than 1, take beta equal to how much? Tell me. You tell the IS code told beta should not be taken less than 1. See, they very clearly told beta not to be taken less than 1. So tell the Excel, when you find beta, if the value of beta comes less than 1, tell the Excel, take beta equal to how much? Tell the answer. Take beta equal to. You put a control there. If the value of, tell the Excel that you take beta equal to 1. Okay. Therefore, for our example, Excel will take beta how much? Tell me. ಇದೆಲ್ಲ ಬರಿಬೇಡಿ ಆಮೇಲೆ ಪ್ರೋಗ್ರಾಮಲ್ಲಿ. Tell me. For our present example, Excel will take beta how much? Tell me now. ಎಷ್ಟು ಬಂತು ಅವ್ರಿಗೆ? 15.4402. Tell me, how much Excel will take beta? If you tell the command, if it is less than 1, take 1. So our example, Excel will take beta how much? Bega bega. Our example, Excel will take beta 15.4402. Right. 4402. Therefore, Excel will get what value? Therefore, Excel will get what value? Tell me. Excel will get what value? Excel will get what value? So Excel will automatically get what value? Excel will get what value? Table ಬೇಡ ಅದಕ್ಕೆ, ಟೇಬಲ್ 90 ನಾಟ್ ರಿಕ್ವೈರ್ಡ್. ಎಕ್ಸೆಲ್ ವಿಲ್ ಗೆಟ್ ಟೌ ಸಿ ವ್ಯಾಲ್ಯೂ. ಆಯಿತು, ಈಗ ಚೆಕ್ ಮಾಡಿ, ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಹೇಳಿ ಆನ್ಸರ್. ಟೌ ಸಿ ವಿಲ್ ಕಮ್ 0.85 ಇಂಟು ರೂಟ್ ಆಫ್ 0.8 ಇಂಟು 25 ಇಂಟು ಬ್ರ್ಯಾಕೆಟ್ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ 1 ಪ್ಲಸ್ 5 ಇಂಟು ಎಷ್ಟದು 15.4402 subtract 1 divide by 6 times of 15.4402. ಹೇಳಿ ಎಕ್ಸೆಲ್ ಹೌ ಮಚ್ ಟೌ ಸಿ ಇಟ್ ವಿಲ್ ಕ್ಯಾಲ್ಕುಲೇಟ್, ಟೆಲ್ ಮಿ. ಬೇಗ ಹೇಳಿ ಆನ್ಸರ್. ಟೇಕ್ ಯುವರ್ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಆ್ಯಂಡ್ ಟೆಲ್ ಮಿ ವಾಟ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಟೌ ಸಿ ಎಕ್ಸೆಲ್ ವಿಲ್ ಕ್ಯಾಲ್ಕುಲೇಟ್. ನೋಡಿ ಗೊತ್ತಾಗತ್ತೆ. ಈಗ ನನಗೆ ಯಾಕೋ ಡೌಟ್ ಇದೆ ಅಲ್ಲಿ, ಯಾಕಂದರೆ ಬೀಟಾ 1 ಕೊಟ್ಟರು, 15 1ಗೆ ಅಷ್ಟೊಂದು ಜಂಪ್ ಬರಬಾರ್ದು. ಎನಿವೇ ನೋ ಪ್ರಾಬ್ಲಮ್, IS ಕೋಡ್ ಫಾರ್ಮುಲಾ, ದೀಸ್ ಆರ್ ಆಲ್ ಎಂಪಿರಿಕಲ್ ಫಾರ್ಮುಲಾ. ಈವನ್ ಐ ಡು ನಾಟ್ ನೋ ಹೌ ಇಟ್ ಕೇಮ್. ಇಫ್ ಐ ಡು ನಾಟ್ ನೋ ಹೌ ಇಟ್ ಕೇಮ್, ಯು ನೀಡ್ ನಾಟ್ ಬಾದರ್ ಹೌ ಇಟ್ ಕೇಮ್. ಬಟ್ ಐ ನೋ ಲಾಜಿಕ್, ಐ ನೋ ದ ಲಾಜಿಕ್ ದೇ ಯೂಸ್ಡ್, 3-4 ಟರ್ಮ್ಸ್ ದೇ ಯೂಸ್ಡ್. ಅಷ್ಟೇ, ನನಗೂ ಬೇಡ. ಸಮ್ ವಿಲ್ ಟೆಲ್, I will tell there is an equation is there, even I got not clarity, then student will tell, sir bitbudi yake sir, if you don't have clarity then we will never understand it. 0.3218 ಬರ್ತಾ ಇದೆ, 0.3218. ಆಗ ಎಷ್ಟು ಬಂತೇಳಿ ಟೌಸಿ ನಮಗೆ ಸ್ವಲ್ಪ ವೇರಿ ಆಗುತ್ತೆ. ಯಾಕೆಂದರೆ ನೋಡಿ, ಇಂಟರ್ಪೋಲೇಷನ್ ಮೀನ್ಸ್, ಸಿ when you got two values you take linear interpolation, but there will be curvature, so slight error will come. Tell me how much value we got by table. It should be very near to 0.3218, then it's okay, we can pass the Excel. 0.3166, that is our value is 0.3166, that is almost equal to 0.32. Okay na? So okay or not? Okay or not? Too little variation is okay. So okay, is it abnormal answer? No. Do one thing, those who are serious ಗೆ ಒಂದು ಕೆಲಸ ಮಾಡಿ, ಅಲ್ಲಿ PT 0.5, 0.75, 1 they are given. Can you check that answer? ಹೇಳಿ. ನನ್ನ ಡೌಟ್ ಇರೋದು ಇಲ್ಲೇ. ಈಸ್ ದ್ಯಾಟ್, ಯಾರು ಇಲ್ಲೇ ಡೌಟ್ ನನಗೆ, ಯಾರದು ಹೇಳಿದಲ್ಲ ಡೌಟು, ಎಲ್ಲೋಯ್ತಾ ಡೌಟು? ಈ PT ಇಲ್ಲಿ ಬರುತ್ತೋ ಅಲ್ಲಿ ಬರುತ್ತೋ ಅಂತ, ಬಿಕಾಸ್ ಇಟ್ ಇಟ್ ಯೂನಿಟ್ಲೆಸ್. ನಂಗೆ ಡೌಟ್ ಇದೆ. ಒಂದು ನೌ ಇಟ್ ಸ್ಯಾಟಿಸ್ಫೈಡ್. ಡೂ ಒನ್ ಥಿಂಗ್, ಇಲ್ಲ ಚೆಕ್ ಮಾಡ್ತೇವೆ ನಾನು. ಸೊ ಚೆಕ್ ಆಮೇಲೆ ಎಂಟು ಮಾಡ್ರೆ ಆಯಿತು. ವಾಟ್ ಯು ಕ್ಯಾನ್ ಡೂ ಈಸ್, ಫಾರ್ PT 0.25 or 0.5 and 0.75, ಕ್ಯಾನ್ ಯು ಚೆಕ್ ದಿ ಆನ್ಸರ್? Because same way Excel IS code calculated, those who are free for PT interpolation ಬೇಡ, 0.25, 0.5, 1, 1.25 etc. Can you check some values? Tell the answer. Yes, check it. If confirmed, let me know. You tell yes sir, checked. Okay. Therefore, now your Excel knows what value. Now your Excel knows tau v value and tau c value. Remember, tau v is the dangerous value. Nodi, tau v is the dangerous value and tau c is the, this is the actual stress. This is the actual stress. This is allowed stress. Excel knows tau c, tau v, Excel knows tau c. If it is the first question, Excel will calculate tau v ಎಷ್ಟು ಬಂತು ಹೇಳಿ ನಮಗೆ. ಟೆಲ್ ಮಿ ಹೌ ಮಚ್ tau v you got. ಟೆಲ್ ಮಿ ಅವರ್ ಫಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ tau v, ಸ್ವಲ್ಪ ಹಿಂದೆ ಮುಂದೆ ಪರವಾಗಿಲ್ಲ. ಟೆಲ್ ಮಿ tau v how much you got. Or lengthwise bending value, for our lengthwise bending how much tau v you got. tau e value you got for lengthwise bending 0.3693 ಪಾಯಿಂಟ್ ಹಿಂದೆ ಮುಂದೆ ಪರವಾಗಿಲ್ಲ ಚೆಕ್ ಮಾಡೋಣ ಆಮೇಲೆ 3693 ಆ್ಯಂಡ್ ಟೌ ಸಿ ಅಲೌಡ್ ವ್ಯಾಲ್ಯೂ ಹೌ ಮಚ್ ಯು ಟೋಲ್ಡ್ ಜಸ್ಟ್ ನೌ 0.3218 ನಮಗೆ ಬಂದಿರೋದು 0.3166 ಆಯ್ತು ಬಿಡಿ ಪರವಾಗಿಲ್ಲ ಲೀವ್ ಇಟ್ ನೌ these both values, so you don't have to bother. Excel only will calculate tau c fast, clear. You don't require table 21 to table 19, interpolation not required. Tell the once in a lifetime, once you feed the equation, that's all. That somebody will do, others you enjoy. Like ready-made food, sometime to prepare a food it takes days together. You have to dry it, to wash it, then you have to make it dry in the sunlight, then so many things you have to do. Sometimes some food items to prepare, it may take weeks. If supplied to you within seconds, you will eat it. That's what happens now. Somebody in the group will struggle, others will enjoy ready-made food. Okay, now, but remember, Excel sheet will not be shared in YouTube. Excel sheet, because Excel sheet you require for ETABS&SAFE, not YouTube class. So those who are in the YouTube, those who are seeing my class from YouTube, not in any batch, you will not get Excel. Where you get it? First of all, I don't know who you are. You won't get. If you give a comment or request me, I will not send. I got other better work to do than doing all those things. And you can prepare the Excel by my technique told. That you can do. You should not ask me that notes portion, that all I require. No, it will be sent only for the group. For you, public information, design I am telling. Okay, now, tell the Excel to see, right here. If your tau e, then see, in the Excel tell, tau e is less than or equal to tau c, or 1 minute here, I will put blue color. You tell the Excel, if tau e is less than or equal to tau c, print what? Tell me. Print what? Tell me. Tell the Excel to print what? If your tau e comes less than or equal to tau c, tell the Excel to print what? To print save over. Print save. Red al beda. Save andre mugito. Save. How much save is not required? We want save. Why? Save means over. But tell the Excel, if tau e value, red value, if it is more than your tau c value, tell the Excel to print what? Tell me. To print what? Tell the Excel to print what? Tell the Excel to print not save in red color. You can tell it to print in green color. Here, tell it to print in red color, not save. Okay. If not save, if it is save, over, leave it. When you do practical design, save, over. Leave it. If unsave, what to do? Tell me. Red will come. If unsave, you should know whether to increase the thickness or slightly adjust the steel. That depends upon marginal unsafe or heavy unsafe. See, suppose you have 3,000 rupees with you. Bill comes to 3,200, 3,400, then you can go to adjustment. You can, suppose, imagine you know the hotel owner. Bill came 3,400. Imagine you have got 3,000. You can go and approach the owner. You are regular there. You can tell him, see what happened is I thought I got money. I got only 3,000 now. 400 rupees I got shortage. And card is not there. What to do? Shall I send someone, or if you want you can send one of your suppliers or bearer with me. I will give the money. Or most probably if he knows you, he will tell, sir, okay sir, give next time. Why? Adjustment. See, that is called adjustment. Suppose the hotel person is unknown to you. 3,000 you got money. 3,000, then margin is lesser. 3,250 is the bill. Then you go to the counter and tell, I thought I have money, card also I forgot now. Sir, mobile madi, phone pay, mobile also forgotten. I don't use mobile nowadays. You tell, mobile has forgotten. So 250 rupees, adjustment required. You see there, any known persons are there? No. Tell the hotel owner, sir, 250 shortage. Most probably, by seeing you, he may tell, okay sir, pay next time. He may take your mobile number. Or, if he is the person is very strict person, okay sir, I will send one now from our side with you. You please hand over the money to him. That way. So, if the bill is 3250 and if you have 3000, adjustment is possible. But remember, if the bill is 3000 rupees, if the bill is 3000 rupees, suppose in the pocket you have 1000 rupees, then he will tell, sir, what is this? This is very bad. You should know when you are eating how much money is there. Shall I give next time? No, he will tell. I won't agree. I know, I don't believe. You may not come next time. See, then adjustment is not possible. Therefore, if it is very highly unsafe, better go for what? Tell me. If it is very highly unsafe, better go for what? Better go for. If highly unsafe, better go for. Charger I removed. Okay. No problem. Nothing to worry. It will be there. Nothing to worry. Oh, charge is still 35. No problem. If it is highly unsafe, better go for increase the depth. Touch mabutte. Okay. Highly unsafe, better go for increase the depth. Danger. Adjust natural. See, increasing depth is called natural remedy. Increase the depth. ETAB, nothing to worry. Go to model, click on the property page, 450 is there, change to 600, run, over. That's all. You don't have to do all the calculation. Okay. Now, if it is marginally unsafe, you can still maintain same depth. Therefore, if unsafe, you tell Excel to type what? A number in red color. That is what? What value? Your tau E by tau C value. Tau E by tau C value. Tell the answer. Because tau E is more danger number. Tell. For our question, Excel will print how much? If it is safe, you tell Excel. Any number required? No. Safe, happy. Thank you. Safe means happy. Over. No correction. Unsafe means tell Excel to type a number of tau E by tau C. Tell what number, you tell it what? Over stress. Over stress number. Over stress factor. Something you can tell. Over stress factor. Tell the number. How much will come? Excel will type how much? 1.166 means tell me how much percentage over stress. Tell me. This will tell you, this number will tell you how much percentage over stress. Tell how much? How much percentage over stress? 16.6%. See, 16.6% is not a very high over stress. Also, not very less over stress. 3,000 rupees means around 16 500 rupees shortage. So therefore, your choice. If it is 1.03, 1.04, 1.05, etc. means you can go to adjustment, increase steel. If it is above 1.1, some people will tell, beda. One better, instead of 450, better go for what? Instead of 450, better go for what? Better go for. It is better. Don't try artificial. They will tell, don't try artificial. Better go for depth of 450 or 500. Or, sorry, 500 or 550. Like, if the bill is 3,000, Alright, if your money in the pocket is 3,000, if the bill is 3,025 rupees, you tell the hotel owner, cashier, he will tell, okay sir, give next time. Or he may tell, sir, you take it as a discount. He may tell, sir, from our side, 25 rupees discount, sir, no problem. If your money is 3,000 you have got, if the bill is 3,100, he may tell you, okay sir, pay 100 rupees next time. He will allow that way up to around 100, 150 like that. If the bill is, if you have got 3,000 rupees with you, if the bill is 3,600, he may not agree. Then better you tell your people, you stay here only, I will go home fast, or I know my friend here, I will go and bring the money so that no embarrassment. Tell yes or no. Or imagine, you know somebody in that road, somewhere you know a person, instead of begging or showing problem in front of hotel owner, it is better to go somewhere where you know him and ask him on the 500 rupai kodi. Tell yes or no. It is better to go to a known person, get some money and save the embarrassment. Tell yes or no. It is better to save the embarrassment of telling, sorry sir, money is not there. So that you decide. If the money is 3,000, if bill is 6,000, then danger. Then you have to do something. Same way. So see, up to around 1.03, 1.04, 1.05 is no problem. Increase steel. Otherwise, increase depth. Now, if you are increasing steel, you don't have to do interpolation. I will tell you what to do. See, in the spacing column, tell me how much you typed there in the spacing column for 12 tor. Tell me how much you typed there earlier. You don't have to do interpolation. In the spacing column, you typed how much there? Earlier, 160. You typed 160. Okay. Retype. Tell what? You should reduce the spacing or increase spacing. Reduce the spacing or increase spacing. You should reduce the spacing or increase spacing. You should reduce the spacing or increase spacing. You have to give it more steel. You have to reduce the spacing or increase the spacing. Reduce. So what you do is, just like that, type 150, press. Suddenly this number will change over to 1.08. Howda? Press 140. This number will change over to 1.03. Yen aatarte janaya. Type 120. This number will change over to 1.01. Higher gracharane. Try 115. Suddenly this number will come 0.998. Clear or not? That's all you have to do it. You keep on changing, typing. You keep on reducing. After some time slowly, 120, type, that's it. Suddenly it will come to below 1. Oh yes, 115. So provide 12 tor at 115, only 110 center to center. Clear? You don't have to go to interpolation. Play with this button, this one, this. The moment you change there, this will keep on changing. This number will keep on reducing. See that number comes less than 1, then suddenly the red color will vanish and number will not come. Suddenly red will vanish, it will give green value. Stop. Tell me clear or not? Those who are seriously attending, I want to know. Those who are serious, fully clear or not? Now, who will prepare Excel? Who will prepare Excel? This week you have to give, because when I go to design of column, I will do one thing. You check this one only. When I go for column footing design with axial load and biaxial bending, at that time to check for shear, I will use Excel. Who will prepare? At least 2 persons. At least 2 persons. Why? One Tushar, I will ask him to prepare. He is right now. He is not able to come to class regularly. He is a very dedicated person. Nowadays, problem, he is watching recording. He will prepare. Nandakumar will prepare. This Excel. All I told, go through recording and correctly prepare. Which are not to be typed, you should remove it. It should be invisible. Okay, prepare it. Others also prepare and check with this value. Because of that 16 torr and 12 torr, slight error will come, no problem. When I go to column with biaxial bending, lengthwise bending, I will ask XL value parallelly. I will calculate here. I will not explain to you. I will calculate here. I may get 0.343. I will ask Nandakumar, tell the XL value. You should tell on that day. Agreed? That is the check for you. When I go to column with biaxial bending, a footing with load and bending, both bending, at that time, one bending, I will do the calculation here. But I will ask you, tell me your XL value. You should tell immediately. Agreed? Okay. At that time you check it. And XL you send in the group so that all the people in the RCC group and all the people in the ETAB group will get it. But remember, send it after verification next time. Send it after it is verified next time. See, I don't have my laptop here. Once I get my laptop, I will also check it when I am free. Okay. Now, 8:49, usually non-stop talking up to 9:30 I cannot take. I told up to 9 I will take. 10 minutes more is there. I can take the class for 10, but talking non-stop this way is tiring. Shall I stop now? 10 minutes, what is there? It's a big issue. 10 minutes earlier. Once I go to software class, class will be up to 9:30, remember. Once I start software, I will not stand like this here. I will sit in a chair there and fan directly on me. Then there is no problem. Then there is no problem. Only because this teaching I stand in the board. That time there is no problem. I will not 9:30. I may extend up to 10 o'clock also if you are willing. If you are willing, that time I will take another half an hour. Come on, let's go for it. But here, this is teaching on a board. So therefore, if I tell further, I will use 10 minutes for telling that only. Okay, I will close. Next week, Saturday, Sunday class is there. Other week, I am going to native place. So I will give some instructions for you. Next week, 15th of this month, I am going to native place for around 10 days. So 2 Saturday, Sundays, I will be in the native place then. By that time, I want to finish complete footing, including axial load with double BM and also combined footing and other things. Everything I want to complete by that time. Okay. Now, we will meet next week, coming Saturday. Okay, thanks.